Going live now.
どうぞ。
はい、DevSecOps Days 東京 2020。
Welcome to DevSecOps Tokyo. We are ready to open the interesting program, and we are now joined by Professor Hasan Yasar of Carnegie Mellon, and also Mr. Mark Miller, along with Dr. Tomabechi. Without further ado, we would like to give the floor to Mr. Mark Miller for some opening remarks.
For your opening remarks.
英語がでかいっす。
Mark, I think you mute yourself. So
I did. I didn't want to interrupt you. So thank you so much. It really is an honor to be part of this event. As the founder of DevSecOps Days and the co-founder of All Day DevOps, it's really gratifying to see the first large-scale event for DevSecOps in Japan and in Tokyo. It's not an easy thing to do to put on an event like this, and I have to say right away, you've done a tremendous job, Yusuke and Hasan, putting this on. It is to get new people, to introduce new people to the concept. It's fantastic, fantastic. I want to start with a brief overview. Tomorrow in my session, I'm actually going to be doing a long overview of DevOps and DevSecOps to get everybody introduced to it. But tonight, I want to do just a very, very brief overview in case people haven't heard of DevOps and DevSecOps and what it's about. So DevOps itself is the combination of the words developers and operations. And when you put those together, it becomes DevOps, the idea that you have one team working towards a single goal. It was first coined by Patrick Dubois in Ghent, Belgium. When he did the first DevOps Days in Ghent, Belgium in 2009, Patrick and his team there really expected, 10 or 15 people to show up for the event. They had no idea what was going to happen. But then the first time, like 70 people showed up, and they knew that they were onto something. From there, it became a global phenomenon. Last year alone, there were 72 DevOps Days events around the world. So congratulations to Patrick about that. When I started first working on the idea of DevSecOps and getting security involved with the development and the operations team, the idea came originally from Shannon Leitz at Intuit. I call her the godmother of DevSecOps. She actually wrote the manifesto and got the whole world interested in this concept. And it started to grow, and it needed a community itself, meetings like this, so that people could talk about how they're bringing security into their DevOps initiatives. And that's where DevSecOps came from. We started it in 2018. So this is the third year. And to have an event of this size, I think we're close to 1,400 people registered for this event today. That is just absolutely remarkable that it is growing like that. One of the problems we had when we first started DevSecOps is the name itself. People started screaming, why do you want to take the word DevOps and put sec in the middle of it? And those of us that believe that security belongs at the table with developers and with operations said the purpose is to make sure that security is part of that team. And then John Willis, who brought DevOps to the United States, DevOps Days to the United States with Damon Edwards, he wrote an article on DevSecOpsDays.com, and he called it DevSecOps. It's just a name, get over it. Because there were so many people pushing back, and that article itself actually helped calm things down, that there really is a purpose here. John tells the story of when he'd go into large enterprises and talk about DevOps. the leader's eyes would glaze over. They just become bored because they didn't understand the concept. It didn't have a business objective behind it. And so John started talking about DevSecOps and realized the eyes opened wide when you start talking about security, because now you're talking about something that can affect the business in a massive way that hits the bottom line. Think about that. When we're talking about DevSecOps, the core of DevSecOps is making sure security is a part of the conversation that you're having. The history of DevSecOps, as I said, started in 2018. As of this year, we're going to have 10 events all around the world. We're having them in London. We're having one in Istanbul. We're having one, we had one earlier this week in Melbourne, Australia. We're having it today in Tokyo. We've got a couple coming up in the United States. The ball is rolling. It's really starting to pick up. So what I want to do is tell you how other people have utilized a day like this in the learning experience that you can get from listening to the speakers. Hasan and Yusuke have really put together a remarkable set of speakers and agenda for the day. And so what I would like you to do is make sure that as you listen, take notes, make notes to yourself about things that resonate with you, because that's what you're going to walk away with. There's going to be so much given to you that it's going to be hard to absorb it all. What you want to do is really have a focus on what's being said and take away what you need from it. So the way to get the most out of the day is to look at the sessions, think about how it's going to affect you and your team, and how you can actually go tomorrow after the conference is over. Is there something that you can do even small, incrementally, that can make a change in your company, in your teams, when it comes to DevOps and DevSecOps? So the overview for the day is we're going to finish up here with the introductions. Then we'll go directly into the sessions. And then there's a set of sessions tomorrow. So check the agenda. You can go to DevSecOpsdays.com. The full agenda is there with the timing so that you can check what you're going to do. So I'm going to end with the idea that having 1,400 people register for a first-time event is massively impressive. It means that the culture in Japan, the culture in Tokyo is ready for this. They're hungry for this kind of knowledge. They're hungry for this type of learning. Our hope is that you'll go back to your teams with something that you can use, and that your teams can use so that you can spread the message yourself and help build the community within Tokyo. I'm sure that there's other teams outside of Tokyo specifically, but in general, in Japan, we think this is a relatively new community that's coming up, and we'd love for you to be a part of it. We'd like you to participate in the local events in your area for DevOps and DevSecOps. We'd like you to host DevOps and DevSecOps events for your company. Even in the remote environment where we are now, where everything is online, you can see that we can do it. We can still do it together as a group and as a community. So what we're looking for is for people like you to come, volunteer to speak. Tell people what you're doing with DevOps, what your team is doing with DevOps, even if it's something small, because it's the small ideas that are relatively easy to implement, and it can start the movement towards DevOps in your team. So do that, introduce the ideas to others. So I'll end with, most of all, I want you to learn something today and tomorrow. I want you to take notes. I'd like you to ask questions. And even more, I'd like you to answer questions, so that when people ask you, what did you hear today? You can check back on your notes and say, well, I heard from Hasan that you could do this. And I heard from Nicholas that you can do that. That's the value of learning at these types of events. So thank you so much for coming. I hope to see you tomorrow during my session. Yusuke, I'm going to turn it back over to you at this point. Thank you so much for letting me host the event here and introduce myself. And I look really much forward to seeing what happens over the next 2 days.
Thank you, Mark. マークさん、ありがとうございました。
Thank you very much, Mr. Miller. Next. Oh, it's not in the program, but we'd like to introduce Professor Tomabechi of Carnegie Mellon. He is also the lead of the Cognitive Research Lab and the Resilience Japan.
Since most of the audience is the Japanese native speakers, I think I would like to speak in Japanese. Carnegie Mellon no
Thank you very much. My name is Tomabechi from Carnegie Mellon University. My presentation will be tomorrow morning, but I'd like to say a few words today since I'm here. So this time, Carnegie Mellon University and Resilience Japan are the main hosts of this event. Of course, American Embassy and the METI are supporting us. As for the content of today's event, it's really up to the other speakers, but this is the first time that we are having this event in Japan. So Carnegie Mellon University probably is not very well known in Japan. I was actually checking the website of the Carnegie Mellon. US News and the World 2018 said that in the area of the computer science, it's #1 in US, and US World Report says that in 2019 in information and technology management, #1 in US, and Hollywood Reporter 2018 says that the School of Drama is #1 in the United States. So looking at this, computer science and the theater are our strength. And so today we have Hasan Yasar from the Software Engineering Institute, SEI. I think it was in 1984, the DoD's budget, with the budget of the DoD, SEI was established. And probably in Japan, it would also happen. For example, Keio or Waseda will set up the research institute with the budget from the Ministry of the Defense. We haven't seen that yet. We have not seen many of those examples. There are about 10 of those institutes in the United States with such budget. But at that time, under Reagan's administration, I think, software engineering and cybersecurity, building such comprehensive institute was given, and that was how the SEI was established. I was in the graduate school at the time, so I remember that very clearly. So SEI is part of Carnegie Mellon, but was established with the budget of DoD and is operated with the budget of DoD. And this time, DevSecOps, it's not the DevOps, we have Sec in between. So security is the focus. And so it's really not US-wide, but it's more like global. And I'm sure you have heard of CERT. And in Japan, METI was hosting, and other institute was hosting the CERT. And the SAI is leading in the area of the CERT. And I'm also at the SciLab. We do get the budget from the university, but it's a lab in the university. So we do the collaborative research with the private sector, and also the police agency from Japan sent some people to us. So, and host in Japan is Mr. Nirahara right next to me. and I'm also the president of that organization, an advisor of a Japanese company. One of them will be presenting tomorrow. Dr. Wells is welcome as an advisor. So it's a company established last year. So this is a major activity of this company, and Miller is also engaged. So I went through them very quickly, and I will be making the very short presentation or greetings tomorrow. So I will see you tomorrow morning. Thank you. So I hand it back to Nirahara-san. Thank you very much. Sorry, I didn't introduce myself. I just noticed. My name is Yusuke Nirahara, and Professor Tomabechi just talked about the Resilience Japan. And this community, well, Resilience Japan has those activities, but today anyone can join. And that has been the purpose of this event. So we are not doing this as a PR activities. We would like to make sure that many people understand DevSecOps. And in order to do so, the professors of the Carnegie Mellon and also Nicholas Sharan will be speaking tomorrow. Okay, then. So now I'd like to hand the microphone to Hasan to talk about the DevSecOps, starting with the basics. Now, in order to understand DevSecOps, we have to first understand waterfall and agile developing and what is the ops, and then look at what is happening with the DevSecOps. So we have to really learn the history and understand the history of the development and operation. So that's something that Dr. Yasar will explain to us in detail. I myself, today, tomorrow, will be acting as a navigator or moderator. So in the Dr. Yasar Hasan's presentation or session, I'll be moderating to interject from time to time so that the Japanese audience will be able to understand this. So I'll be like a teaching assistant. So now I'd like to hand over to Hasan.
Thank you so much, Yusuke. Thank you. It's been an honor to be part of this. It's such a great event. I'm really excited. Remember that we met together almost a year ago in CMU. So I mentioned DevSecOps to Dr. Professor Tomoyachi as well to you. I didn't know that we will go so fast, get DevSecOps days in less than a year. We planned early this year, but unfortunately because of the COVID, we couldn't make it as in person. But I'm really excited to see the number is increasing and there's an interest. And I believe strongly that everybody needs DevSecOps, and that's another evidence that we think that DevSecOps is necessary as well in Tokyo too. So I'm going to start to share my screen with my slides, and I want to make sure everything is okay. Let me start with my screen. All right. So we are good to go. The screen is visible? Perfect. So I'm going to talk about DevSecOps process implementation, and Mark Miller said about a little bit of history, and Yusuke said that DevSecOps. I really would like to cover up what the fundamentals are, why we are doing DevSecOps, what is the reason, what is really changing with the current software methodologies, how can we make an effective software development process, how we can be effectively and putting a security in place as an actionable as part of DevOps. It's not just a name, but there's a movement, there's a practices behind it. So I'm going to talk about 3 hours on this concept, talking about all the principles, all the components, what you should do, understand the common vocabularies like continuous integration, continuous delivery, etc. So I'm going to cover up like all these components. I'm going to make sure that you understand overall what is real DevSecOps, what is the science behind it. It is not just a term, it is a reason, there is a science, there's engineering principles behind it. There's some principles and practices behind it. So I would like to make sure that you understand what it is and what the common principles are, how it is going to affect into my business, how can I use some of the components, and what is the things I should do in my organization to establish DevSecOps. So I'm going to cover up this. I wish we have more in person, but if you have any questions, please put in the chat room, either in YouTube or somehow the contact with Yusuke, so he's going to ask me the question during my presentations. So let me talk about myself a little bit. So I have been doing the DevSecOps for years, actually, even though I started, but I have been in software development 25 years. I am part of the Carnegie Mellon University, and Dr. Tomoyachi mentioned as well, CMU is the #1 computer science school in US and top 10 in the world. So SCI, Software Engineering Institute, is part of the Carnegie Mellon University. So I'm a technical director at the Software Engineering Institute, then managing the group. The group does the DevOps, DevSecOps, and Agile, looking for the more modern software technologies and helping mainly for Department of Defense, but also we are helping to the industry and helping the organization, and also with a lot of research activities. So research activity like looking for what the new things are, what the problems are, how can we evolve technology, how can we evolve the software pieces, make it useful, what are the barriers are, what are the problems are. So we have been in research as well. And also I'm teaching a software security class as well as part of Heinz College, again, part of the Carnegie Mellon University. And also I'm teaching a DevOps course since 2015. And that was the first DevOps course in the world, by the way. Nobody was talking DevOps as a course in the graduate level. So CMU was the first university offering a DevOps course as a graduate level for the master's students. I start with the 5 students, 1 semester. Now I have 35 to 40 students every semester, spring, fall, and also the summer as well. So there's a lot of interest. Many reasons people are interested. I'm going to cover up the rest of my presentation, but people are interested, either engineering side and business side, or sometimes the user. So there is a need behind it. So I'm teaching as class as well. So I do the IEEE membership as well in terms of building the standardization, some other component. So Dr. Tomoyachi mentioned who the SCI is, what the Scilab. They are part of the Carnegie Mellon universities. So SCI is the Software Engineering Research Lab, and Scilab is more about the privacy and security, which is another kind of a similar institutional level, but there's more oriented research and more free research between industry and also the academia as well. SCI has more restrictions because we do more about the federal funded research lab. However, we do research component too. So that's what we do. As also third part of the SCI. So let's start DevOps foundation first, right? So what is really DevOps? Can somebody define DevOps for me? That'd be great, right? You may be hearing a lot. So let's start the vocabulary first. So I'm going to come up with DevSecOps after that, but we really understand what the DevOps it is, how it is started, what the components are. It's basically a set of principles and practices which enable the better communication, collaboration between the stakeholders. I know it starts with the DevOps, but actually it's requiring to have more collaboration, more communications, more talking with the other stakeholders. So other stakeholders, I will expand more. Other stakeholders are a business and legal perspective and testers. So there are many people are involving and building the software. So DevOps is bringing these people together as kind of a practice and process, also helping to go faster, putting a techniques behind it. So what is DevOps? Isn't it? DevOps is not a system engineering tools. It is not a waterfall. It is not just a tool. It is not just buying something from a vendor or from a software that expected that it's going to work in an organization. It's not. It is not a tool, basically. There is no such DevSecOps tools available. There is no such DevSecOps or DevOps process like the tooling per you can buy. It is not engineering thinking. It's a set of principles and practices. So we should understand that. And also that definition from IEEE 2675, it's going to release sometimes this month. That will be the first DevOps standards as official from IEEE and ISO. And there's a lot of, as I said, there are a lot of definition in the industries, and every people are trying to define what they're understanding, what the organization are thinking. So as an IEEE, we ended up this definition. So IEEE documentation and standard will be released sometimes in October. So if you're going to really look for the overall perspective, I really advise you, and sometimes in November timeframe, and check it out the ISO or IEEE website, and you can download it and you can use as more guided implementation details. So let's continue and really how it started. And briefly, Mark Miller mentioned and how it started. So I'm going to go a little bit deep the first time because we have to understand how it really started. What was the reason? What was the why it started DevOps? So then we will think about and then the solution perspective. It should be the same question for yourself. We have to think about why I need to change, why I have to change. What is the reason I have to change my methodologies, my process, or my system that is not working? Or how can I improve myself? That's exactly how DevOps started. The first time, Patrick DuBois and then Andrew Schaefer, they proposed a topic about Agile infrastructure and operations in one of the Agile conference. Why? The Patrick and Andrew, they are both from the operational team. They are both responsible for the production environments. They were really upset getting so much changes from a dev side of it as a result of agile thinking. They said, how can we change ourselves and how can we be agile in the infrastructure perspective to address the demand from the developer side? And he wrote a paper as well, which is on the screen. That was the first paper written for Agile infrastructure back in 2008. The first time DevOps term was mentioned from John Alspo in Velocity conferences around August timeframe. Then finally, October 30th, DevOps Day is born in Belgium as the first time that event happened as a DevOps Day. So that's kind of a little bit history. So how it really started, as I said at the beginning, it's a movement. It's based on the reaction. So in the reaction, it's basically how the dev team are giving it application or a systems has been built and coded and giving a team that team is responsible to maintain. So exactly, I like this picture a lot. It looks like work fine perfectly in my laptop, in my environment, but it is not working the operation. It's the house is burning. It's becoming an ops problem now. That's exactly what the definition it is. In some organization like DoD, there are many handoffs. When handoff means like I'm a developer, I wrote my code, I build up my system, and when I transition to the other team members, my organization, that will be very challenging. There are a lot of risk in between. Every time when we have a handoff, it is becoming some misunderstanding or misinformations. Think about the complex systems. It's very challenging of its component. I'll give many examples as well. So what is really DevOps? Waiting for deployment without DevOps, that's going to be a Robinson example. Waiting for deployment, when it's going to come, as a user, think about the user for yourself. If you don't have a new version of application that meets your needs, then you will be getting angry or nervous sometimes. And ask yourself, and we would like to use the latest and greatest phone sometimes, right? We would like to update immediately with the new version of operating systems, iOS 14 as an example, or the Android 10 as an example. We're looking for better software all the time. How is that happening? All the modern industries, which is Google does, Amazon does, or the Apple does as well, they're using a DevOps techniques behind the scene with agile thinking. So overall, it's basically an extension of agile thinking, expanding the agile thinking that how it started at the beginning and carry over to the operational side. So including the ops team as well as part of our developer-centric mindset and expanding the operation as well. But DevOps is beyond that. I'm going to explain this. So we don't want to be in a position like Robinson Crusoe waiting in the island and somebody's going to come us and pick us up. No, we're going to go fast and quick, but it's not that easy. Let's open up a little bit. When I said extension of Agile, what that means. And agile mindset is a constant change. So constant change means like, I would like to do something new. I would like to have some new features, some new capabilities, or new requirements to meet the user needs. But as you see on the screen, it's really covering up only this perspective, like covering up, analyze, plan, and develop and build this perspective. It's not really responsibilities on the kind of left side of the life cycle. When we say shift level, I'm going to explain as well. It's more, we're not thinking about the test cases, an example a lot. We're not really thinking about the deployment perspective. And maintain, never ever. Nobody's really thinking about the maintaining perspective on agile. It's not a definition of the agile components, isn't it? So DevOps is really taking the mindset of agile, expanding with the constant testing, a continuous delivery, including operational team. So operation team is really big. When we say operation, security is part of it, and compliance team is part of it, and IT team is also part of it. So under operation umbrella, many other stakeholders also are part of the operational concept, and they are responsible for deployment and maintenance perspective. So let's open up to what agile means. So this is kind of a definition of agile. It's iterative, incremental approach to software development practices. So instead of really creating a very rigid requirements, we would like to be more easy or less requirements. Still, we know the overall system design. Still, we should know about the requirements, but we would like to go more iterative and incremental perspective. When I say iterative, let's try something as new capabilities. Let's see how it's going to work out. Let's see, are we able to address the user needs? Let's see our design is going to work or not. So this is kind of like a more iterative perspective. Incremental, we will start from the small features and adding more features on top of it. Adding more features, eventually we will have a complete system and software is built. That's what the iterative incremental means. So there are 4 tenets and 12 principles of Agile Manifesto. So a group of engineers and get together back in early 2000, around 2002-ish. And because of the waterfall mindset, not a waterfall paper, by the way, waterfall mindset, since the organization are building a software, when they built the software, they were so much focused on paper. They were so much focused on each of the phases of life cycle, and then work was not delivering on time. So a group of engineers get together, they said, let's be an agile. That's how they came up some manifestos and then the principles as well. So the 4 manifesto says, like, pick the software, then we are building the software. Make sure the software is working instead of having a very comprehensive documentation. Or be responsive to the change and more, not really more planning. So really, it's kind of like a balance. In old days, without having an agile, this side was more heavier, which is the waterfall. You see on the screen, like process, comprehensive documentation, etc. And then interactions or working software was less important. So agile is bringing a level of, depends on the work, depends on the customer, of course. End of the day, we would like to deliver a working software. That's what Agile Manifesto says. It doesn't mean we have to stop the documentation. It doesn't mean we have to stop the process completely and no plan either. So the first things as the myth, change your mindset. If you are thinking Agile is just a write the code without doing any documentation, it's wrong. We have to have some documentation. It is not comprehensive, but some documentation is important to us to achieve our business needs, to achieve the software, to achieve what we would like to do to deliver the software. So we have to find a balance. So if you're a developer in your organization, if you're a manager, and ask yourself a couple of questions, like how can you put a system in an environment or a software in a coded environment and somebody can maintain after that person? Or how can you build up a code base that can be used and maintained many other developers? And immediately you will ask yourself, yes, we have to have some sort of command in the code or some sort of lesson learned. So we're going to build something as we go. So you have to really find a balance in your organization. If you are in the safety critical systems, if we are building a healthcare related systems, then you have to have a compliance perspective. Then you should be aware of it. And if you are compliant with the GDPR, let's say you're building a software and you're selling to the Europe, and your company is compliant with the GDPR. So you have to create a lot of audit and requirements and documentation for GDPR perspective. And tomorrow, one of our speakers will talk about more and privacy perspective. So overall, you have to find a balance. The question you should ask yourself, and you see on the screen, ask yourself, what is the working software and comprehensive? You can find a balance in between. So there are 12 principles. So there's a 14, as I said, kind of like the framework, but there are 12 principles on the Agile principles as well. So I don't want to go to each principle. You can go to Agile, the website, and manifesto.org, and you can get it from there. But if you look at all these principles and expand it off the 4 tenets, looking for a continuous delivery, continuous perspective, and working for the simplicity, which is the more loose architecture, looking for a short interval. So it's defining what the Agile principle, what the frameworks are. Again, so far, we never talk about some techniques, but we are talking about the very high level as a framework, what Agile means in the software world. So as an example, like one things in Agile mindset or Agile working, so we understand the overall perspective, what Agile means. And the bottom is you can use different techniques to achieve the Agile process. You can use the Scrum, which is on the screen. This is the Scrum level working, and what the Scrum means, I'll explain in a minute. And the Scrum methodology is one of the Agile process implementations. So if you remember, the Agile is not saying what type of process you should do. It says you have to this, the principles. And how you achieve that, you can achieve, depends on how you're going to define. You can define a process that you all agree on it, and you can name it on it. You can say, this is a new process, as the DevSecOps process is an example, right? Or this one is the commonly known as a couple of examples, like a Scrum and Kanban, extreme programming. These are the couple examples of the Agile implementation. So specifically for the Scrum methodologies as part of Agile thinking, when we build up any systems, we are creating a product backlog. So what the product backlog means, like all the features. As an engineers or a business owner, we're going to build a system, right? We're going to build up a software. We will write what the features are, right? All this possible feature, which is converting the user requirements into a list of the wish list of the requirements, list of the things. It's kind of like in a written format in the DevOps environments. And based on the product backlog, somebody's going to prioritize that backlog. Somebody means like either a business owner or the security persons will get together as a team and prioritize the backlog and creating a short interval. That short interval can be minimum 2 weeks, sometimes 1 week, but usually 2 weeks up to the 4 weeks. This is the interval. Remember the Agile principles? We said incremental iterative, right? So we would like the iterative. So we're going to try something and deliver something to the user, get the user checked in this process, and then go to the next one. So every sprint, about 2 to 4 weeks a duration. In that duration, team is building a software or a system. It's shippable. Shippable means like user can see the result. We don't want to be building Agile in our dev environments. And every day, teams are getting together for a 15 minutes or 30 minutes talk where we are, what we should do. So far, it's great, right? So far, we focus on the methodologies for developing your systems. You see that a lot of things is missing, right? I'm sure your head is spinning. It's not right. Something is spinning, like something is not completed yet, because we haven't really spoke about the business need yet. We haven't really talked about any operation, any risk security at all. We haven't spoke about anything yet. So let's continue. So overall, Agile method is initial planning until deployment. It's kind of like a circle. We took the one features, got another one, got another one. Continuously, we are building. So immediately, I'm sure you already popped out the heads in your head. So we're looking for what we can do. What we can do, we deliver something to the user needs that user can use, and they can give us a feedback, which is evaluation piece for us. Like we design, we build it and deploy the user going to give them feedback to us, and we can address the feedback from the user and put a new version to the systems. It looks like simple, but there are a lot of difficulties behind it. Let's start what difficulties are behind it. First, and in the typical software organizations, we can expand more. We have a group of people are focused on their work, like developers are focusing on the developers' jobs. And operational teams are focusing the maintenance of the site, and QA is the quality people, QA and testers and analysis people, and analysis people are the business analyst or the data analyst. So all people are working on their work environments or their purpose. Like QA people are very focused on the quality attributes, what the quality of these applications are. They are building a lot of test cases, a lot of quality attributes, try to make sure that we have right quality. So everybody is really focusing deeply in their expertise. So what's really happening if people are focusing on their expertise? So let's look at another perspective. When we have a focus deeply into the expertise as the requirement, like analyst teams is defining what the business needs are, what the user needs are for the requirements. So if they focus more in depth each of the phases, it is creating some waterfall hierarchy. So waterfall hierarchy means I build my requirements in this phase. I build everything as requirements. I have a great requirement documentation. I wrote everything else what the user wants, and handing over 100 pages, maybe more than 100 pages documentation to the design team, and so on and so forth. So every step is kind of completed, go to the next one. Completed, go to the next one. So if you have a siloed team, every team are focused for their work, for the expertise, and creating a waterfall approach. So one finished task, another person or team will pick it up. So imagine that what type of problem you may see in this step approach, in this waterfall hierarchy components. So what Agile bring that into the picture, Agile brought a team concept of a cross-functional team. So in the cross-functional team, requirements, analysis, and design teams are working together in the sprints, right? They are focusing together. So basically, let's go back again. We can get requirements, design, implementation team together so they can work building the shippable products, right? That's what Agile does. Bringing a team together in a short sprint. Today is October 1st, actually, not today, it's October 5th. So technically, starting that day, you can add a 2-week sprint, and based on the sprint or 2-week sprint, you can plan it, and then you can, here's my demo as an example. So bringing a team concept. But this team concept is missing one component, very important component. It's not in the Agile manifestos. It is not in the Agile principle as well. So what is really missing here? I'm gonna come back. If you do just this Agile team concept, so as a dev team, we are doing a Agile development methodologies in the middle of the screen. So I like this graphic a lot, and that came from Jez Humble. He's the author of the continuous delivery book, and also he has many other books as well with the concept of continuous delivery. And also another book, actually, I really like that Accelerate book with the Nicholas Forsgren and also Jin Kim. It was a great book. And also they did a lot of research as well as a DORA organization. So anyway, he brought that concept. I really like that. As a development team, we does the Agile work as a dev team. When we ignore the other side, which is the team composition, I said it, like ignoring the business side, ignoring the operational and QA side, it is becoming a water scrum fall. Even though we said we don't want to be a waterfall, we are doing Agile great, but we don't add the other components, other stakeholders into the picture, it is becoming a water scrum fall. So our intent was being an Agile, but we can do Agile in our dev team. It is not guaranteed that that we are doing a perfect agile in organization. So we have a siloed agile thinking in a dev team. It's not a good model because we ignore other elements. So what DevOps is bringing all together, DevOps is really bringing all the peoples are responsible, or they have a right to say, or they have a right to say in this the life cycle perspective, right? This is a typical life cycle of DevOps work. Like you can start from project inceptions, you can configure the project, then you can deploy and commit, etc. It's a continuous. So this seems very familiar to you, right? An agile mindset, but getting everybody in the organization so they can be part of the overall deployment practice and perspective. So what is DevOps team? It's bringing agile team together with operational team. Hey, yo, like I'm here as well. Operational team, secure team, I'm part of it. Now we are including the operations team as well into our agile team to eliminate the waterfall approach. So why is important? Why bringing the teams together? So when we bring team together, remember the problems. Remember the problem I said at the beginning, right? The big problem is when we get the small team groups together, when you push into the operation to the deployment environments, typical process are in a work, in application work, we have a dev teams, we have ops teams, we have security. So we are basically building the code. We can do internal building in the agile mindset with the small teams. If you have multiple teams are working in the projects, so usually most of organization, mainly in US, like the highly regulated environment, which is DoD as an example, they are building every 6 months. So every 6 months is building. If you build your systems every 6 months, this is what is happening. So basically, it's becoming a really dumpster fire when you try to build large chunks of the softwares integrated, because every team is building, every team is writing the code. Think about a systems of systems complexities. When you try to merge end of the 6 months, luckily if you can, then if something is really happening, there is no way you can go fix it. It's becoming a fire situation. What we would like to do, we have to eliminate the fire. We don't want to have fire end of the 6 month. We don't want to be seeing any type of a situation when I say fire, like the integrators, engineers are with the panic mode, user wants to have something, they cannot have it, and you don't know what's going on. So I'm sure you all experienced that type of integration. So integration of the code is important. So when you integrate at 6 month, it's becoming a fire situation. And you can really respond to needs, but you have a lot of destroy. You may destroy something. You may have to change some business needs. So it's becoming a large chunk, which is hard to deal about it. It's an exemplar of the fire. Another reason we have to do early fixing instead of a 6 month fix, which is another way of talking about the fire examples. When you have a change, it is requiring of new features or new architectural changes. And this is basically the statistics showing that if you have a change in the production environment, this is going to cost you a lot. Cost of the changes will increasingly a lot when you have a change in the production environment, which is everything is done. You put in the production environment, it's ready to go. So we would like, as a business owner, we would like to have a change as early as in phase of life cycle. Like as early as means having a clear understanding requirement is great, but as a user, sometimes we don't know what we're asking about it. As a business owner, you don't know what the user is really expecting from you. Is the right product you're building? Is it going to hit the target or not? So that's when you have to go like a very small features and test the users. Are they like it or not? So it's going to give you a more easy to change any type of software in early of life cycle coding and testing versus at that. So that's the reason we are looking for agile perspective. All right, let's continue. So why it matters in DevOps perspective? What DevOps is bringing as integration, as a continuous integration in a days. instead of having a 6-month, it's waterfall approach, or a 2-week sprint minimum, which is agile thinking, with a DevOps mindset, we would like to integrate the code from different dev teams, including operational team. We would like to really ship the product into the production in the user environment. We can get a feedback from the users. At the same time, we can get a feedback from the security perspective that we are delivering a secure product. We're not just delivering a product, it is working. We're delivering a secure product, it is running an operation environment. Every integration, every test, and every integration perspective. So it's becoming a days right now. So like we start from the 6-month, we get the 2 weeks. Now we are talking about a day minimum. That's what the integration means. That's what the DevOps bringing with the team together. Right? Oh my God. Comparing DevOps with the world of hierarchy, that's really as DevOps is coming up. So what is really bringing DevOps all together? Bring about the 6-month to the days. So it's switching the DevOps practices. It is going to reduce any type of required time to integration. And also there's many other problems we can eliminate that. So I'm just going to pause it here. Yusuke, do you have any questions from audience? Any question from chat window? I know I would like to have more interaction if possible, but
Yeah.
it's very hard. But if there's a question, I have to answer that.
Yeah, I was also thinking to pause a little bit now. And I'm looking at the chat windows, but not many, yeah, there's not a question.
Okay.
皆さん、どうぞ、質問をぜひ。
If you have any questions, please raise the questions. I am looking at the chat window.
Also add something with summarizing so far, like you talk about like 35 minutes or so.
Sure.
Yep. I'll speak in Japanese. ここまで
So far, Hasan has been talking about the software development history part. In order to understand DevSecOps, it's very important. So I'd like to add a few things here. So to begin with, waterfall methodology is, as Hasan has explained. So this is like constructing a building, let's say a 30-story building. So if you are going to build a 30-story building, you can't start building without planning, first of all, how high the ceiling will be or how many poles and steel bars you'll need. First, at the design stage, on paper, or maybe you might use 3D, but you have to have a design picture. And then the construction workers will base on that and work. So in software building as well, you have the design first, and then based on the design, the developers will build it up. And then finally, you test it to see if everything is done as the requirement says. So this was called something like the V model in the past. You have the requirements here, and then you have the design based on that, and then you do the building part, and then you test it, and then you make sure that whether or not the requirements are met. The users test that. So that's how things worked. And actually in Japan, we are still going through this V model or the waterfall methodology. Well, then why DevOps or Agile came about? If I can add a few more things here. In the past, well, even now, the things that were built in the V-shaped model were systems that would not be affected by the environment. For example, commercial computer systems, the early ones, if I remember correctly, initially it was to calculate the salary at General Electrics. So the first ones were for salary calculation, and Accenture, or rather Anderson Consulting, were involved in the development of that system.
But calculating salaries or payment, you understand what the input is, how many people work for how many hours, means how much you pay to each individual. The rules were clear and everything could be automated. So once you design, it doesn't change that much. Accounting as well. Once you have a system in place to come up with the necessary financial statements, well, unless the tax rate may change, but that only changes every several years. So the software development of the past were based on set requirements, and the requirements didn't really change that much. So just like building a 30-story construction, once you build it, it's going to remain there for more than 50 years. I am living in a condominium, but yes, maybe you don't want to change the height of the ceiling, even if you are living in a condominium. So, for example, YouTube that you are watching, the function of YouTube is really changing very rapidly. Just a little while ago, live streaming was not possible. Initially, there were no ads, but now we have a lot of ads. There were no premium YouTube, but yes, and we now have YouTube Premium. The button places and the color of the buttons have also changed, and the text fonts have also changed depending on the needs and response of the users. So the initial design and the initial requirements, depending on the user's response and depending on the social changes, as well as the competitors or competition, very speedily, you have to respond and change in order to maintain the competitiveness and the services that you're provided. From the back office business, at the front end, you have to satisfy the customers. And I believe Nicholas Shalan will be talking about this tomorrow, but the DoD also has started thinking that transformation is necessary, and they have been working on that for 2 years because the external environment is changing, the technology that is available is changing. So you want to really respond quickly to be able to use these things. And if you want to do that, it means, and it's actually what Hasan has been saying, the old technology stack, waterfall type methodology is very inconvenient. So it's like rebuilding a building that's already standing. So why not start by thinking that it might change along the way? So make it in a way that is easy to change. So in the V model, the testing happens at the very end, but in a waterfall methodology, if you change one part, you have to test it to make sure that it doesn't affect any other areas before making sure that it's really operational. But if you are building a system that the requirements might change on a daily basis, you can't test everything every day. So automated testing becomes necessary. So the services and also the competitiveness of a company, the response of the customer, external environmental changes, how do you speedily respond to these things? The system on the backside has to be able to respond to all these changes. So let's say a Toyota car, it has software mounted on it. If you have a 5-year-old Toyota car, it was a system made 5 years ago. You won't be changing that system on the car, but if you have a Tesla car, the software could be updated from the outside. You can add new features and functions on top. And that is now how cars compete. And so in the same way, software development is changing. So that's my additional explanation. Oh, maybe we have a question. Let's see.
Awesome. We get some questions from audience. And the question is about the philosophy of agile software development is where did this philosophy came from for the agile development? That's one question from our audience.
Okay. All right, let's go take a look here. So the first time Agile Manifesto came a group of engineers in early 2000, and they get together like a volunteer groups, about 13 engineers. If you go to agilemanifesto.org, you will get more information. That's how Agile Manifesto started in 2000, early 2000, 2003, early days. So in 2000, they start. Basically, it's not a person, it's a group of engineers get together and build up that Agile Manifesto as a result of waterfall thinking. Right? Any other questions, Yusuke?
Yes, we have a good questions. We have some good questions. How do you shorten the life cycle of DevSecOps? And also, what is the measure to shorten the life cycle? And also, what is the hurdle to do that? And he thinks about engineered skills and tools, but what is the problem or hurdle of the organization perspective or culture perspective?
Great question, Yusuke.
Yeah.
I will cover up each topics in the next couple sessions. So I don't want to answer right now. Hold it, because we're going to cover up the culture pieces. We will talk about organizational perspective. We will talk about the tools. These are going to cover up. Just bear with me. I'll cover up all of them. There's not one set of solutions. So there is a culture, yes. There is a operation environment, yes. Infrastructure pieces, yes. I'm going to cover up all of them as next follow-up session, Yusuke.
Yes, sure. And other questions from the audience is for the huge, really huge for development, the software development, is the DevSecOps is applicable for such huge software development? And what are the challenges to deliver successfully with such huge software development with DevSecOps way?
Another good questions. Yes, it is applicable, and the biggest consumers in US Department of Defense are using DevSecOps. It's an example for you. There's a hardware pieces, there's a software pieces in it, hardware and software together. In the systems of systems, in a complex level, in a hardware embedded systems, yes, it is possible. It is doable. Another example, like a Tesla or the SpaceX, they're using DevSecOps with agile mindset. Google does all DevOps work behind the scene. Many other industry organizations are using DevSecOps. Autodesk, another one. So it is applicable, it's usable. Yes, we can do that, but it is not a one-team job. There are challenges as well. There are many challenges. I will cover up the challenges on my keynote tomorrow. There are many challenges. I will give some strategy. But we have to understand the basic fundamentals first, because the biggest challenge is not understanding the engineering behind the DevSecOps, because people are jumping to a tool perspective, because people are jumping directly to the building software without even thinking architectures behind the scene. So there is a reason we are seeing some challenges. So let's understand the fundamentals first. Let's understand what it is. Let's understand engineering and science behind it. Then we will overcome that challenges much easier. We can implement it as well. So that's today's session. Actually, I'm covering up a very important engineering perspective of DevSecOps. I'm not going to talk about what the tool does. I'm not going to say what the Jenkins does for you, but you have to understand the business. You have to understand the reason. You You have to understand the engineering components behind the DevSecOps. Then you can implement it. That's the big problem. So I really wish all of you spend the time to understand all these courses. Again, this is a course I'm teaching at the master's level. I'm teaching about a very expanded version of this course and talking about the deployment strategies, talking about each of the architecture's components to make sure that we are able to deliver DevSecOps. People are failing because they don't know the requirements, because they don't know organization structures, because they don't know what the deployment architecture requirements are. They don't know what the security requirements are. They don't know what the security policies are. They're failing because of not understanding. So I'm going to cover up more. Stay tuned with me. So it's going to be a good session today. Any other questions?
Other questions? Maybe it's good to ask Nicholas tomorrow, but I will ask you also. But why resilience is important for DoD? Or maybe we can ask Dr. Wells as well. He's ex-DIO, so tomorrow also we'll cover it. But what's your opinion? Let me.
My opinion is, and I'm going to cover up the next chapter about infrastructure piece. Resilience means your system should be two perspectives, should be strong enough so adversaries will go somewhere else to attack the systems. Second is you should be very responsive to any outage in the systems. Your system should be very resilient, very strong. So you have a lot of testing you have done already. So you already covered up a lot of edge cases in your system they are rebuilding, and your system will behave well in the production environment. Like load as an example, which we focus a lot. Number of users as an example. With the security perspective, we would like to make sure our production environment is not breached or very strong to breach. Putting all the security elements, security testing, security integration, all type of pen testing, red teaming, that will help you to build up a secure systems. And other elements of DevSecOps make it more resilient. If the incident happens, we should be so quick to respond incident. If the data breach happen in our organization, in our website, in our systems, we have to patch that piece of code as early as possible, as quick as possible. In a matter of minutes sometimes is important. To achieve that, a fast response time, fast patching, requiring a DevSecOps, requiring automation, requiring infrastructure to become a resilient. So it's a requirement to be resilient. But to achieve that resilience, again, you have to build up a continuous integration. You have to build up a continuous deployment, continuous security. You have to have infrastructures in place to achieve the resilience. So you need all these components. We are teaching today what these components are, what the continuous integration means, what the infrastructure means, so we can build up a resiliency from bottom up with the right culture, so we can be responsive to the organization. So I'm going to cover up more in my sessions.
Okay.
So you want to proceed?
Yep.
All right.
Are we on time?
Actually, my intent is to get more questions. I don't think so I can finish up all the slides. Let's see how much we can go. Okay.
Okay.
So there are 4 principles of DevOps. It's the same as true for DevSecOps as well. Security is just adding everywhere else, okay? Everywhere in these principles. So first principle is the organization, which we heard the questions, the collaborations, culture. Creating a cross-functional teams is a big cultural problem. It's not easy to create a very collaborative culture, which is a cultural issues. So you have a culture, and you need the infrastructures in place, including all the assets, all the software that we are building, all the configuration elements. Everything should be as coded, as shared in a centralized environment infrastructure code. And then once we have infrastructures in place with the coding perspective, then we have to automate every manual steps as much as possible, including deployment, including testing, provisioning. Any manual component should be automated in the software building, software deployment, software testing, even including a review perspective as well. Then another elements, remember we said iterative incremental, we're getting a user needs, we need to have a monitoring. So monitoring is basically having a metrics on our software delivery environment. We can monitor every behaviors and systems logging, system measurement data we are collecting and sharing all team members that we know where we are heading. We know what the operational requirements are. We know the direction, we know the policies, we have to monitor that. So 4 principles is important to establish the DevOps. But there are requirements that establish that. So I think we can skip that, we already covered up. So there are multiple dimensions of DevOps. So we said that 4 principles, but to achieve the 4 principles, what is the requirements to achieve that 4 principles? Like a collaboration is important. What is the requirement to achieve the collaboration? It's the culture is the requirement. We have to change our culture. We have to change our organization culture. It is not the one culture, one group does that. It's everybody in the organization should think about the same business, same mission, same goals. There is no me, actually. It's going to be a we altogether, which is a culture piece is important. We have to have a right process and practices. Processes and practices should be in place. Like we would like to make sure that, and our team members are using the systems, building the systems as we describe in today's session, like describing what the continuous integration means. They have to follow up the continuous integration principles. They have to follow up the continuous deployment automation perspective. They have to pipeline the streaming. We have to have a policy and practices enable them to continue and fast with the process and practices. So for the automation perspective, we have to have all the test cases should be automated as possible. If your test case is not automatable, then you cannot achieve automation as an example. If your infrastructure is not able to automate the provisioning, you cannot build up an automated test harness as an example. Then if you don't have tools that you're using, such as static analysis as an example, if your static analysis tool is not able to automatically share the data with the stakeholders, like using a chat ops or systems other component, you cannot achieve automation. Lastly, the most important one is the system architectures. So our architecture should support iterative incremental development. Our architecture should be loosely coupled enough we can build up in every iteration, every integration. We can deploy the features to the users in production environment as quick as possible. That really depends on system architecture. If you build up a monolithic architecture, like a big scale architecture, there is no way we can do that. That goes back to the one question that we heard about the systems of systems. If your system is modular, if your system is such as microservices concept, if it is a service-based, yes, you can achieve the DevSecOps easily because you can apply the integration principles on each of the services, each of the modules. If your system is decoupled from each other, not dependent each other's, yes, you can build it. So if you build up a systems very connected in terms of you cannot, other than the other components, you cannot achieve the DevSecOps. So you have to have a loosely coupled architectures in the systems. So one example for the business perspective, this is the only study that came from the DORA, DevOps Research Assessment Group. They did a couple years of survey on the DevOps, and they came up to what is the return of investment. So that's kind of like a money side of it. So high performance team are able to eliminate the rework is basically 13 million as a 1% rework for them if they eliminate that. And then the low IT performance, it's costing them $93 million as the rework. So if you do the DevOps in an organization, it's going to eliminate the rework. So rework is basically costing a lot of money. If you have a 1% rework as an example, it's going to cost you 13 million. Low IT, 93 million. So we would like to be very high IT performers so we can eliminate the rework. High IT performer is basically requiring a DevOps as an example. That's the numbers on the screen. So that's the money side of it. How is it really eliminating rework? Remember that we said if you address the changes in early life cycle, then you don't want to do the rework on design and coding and testing, because you are able to catch up early indicator of the user like it or not, or in experiment with users, then user will use and get the feedback to you as early life cycles. You're eliminating the rework, basically recoding, retesting, redeployment. This is the purpose of DevOps. It's helping. So let's summarize all together. So benefits of DevOps is really reducing the errors during deployments, and time important, like reducing the time to deploy and resolve any errors. And also we're looking for a traceability perspective. Remember the question I answered about the resiliency. Resilience is important to be responsive to any needs, including business. How you can be resilient? You have a traceability from your life cycle. You know all the components is being used. There are many examples in the data breach that happened for years for us. Either we don't know where we are using the vulnerable code in our infrastructures. It's later, we are not aware of it sometimes, because we never able to keep track of which components are being used where. We don't know in our organizations. With the DevOps mindset, you should able to track every little piece of code is running where. I'm going to explain how. That's what is really bringing the DevSecOps about the tracing each of the components running where in infrastructures. One important element I would like to mention here, so far we covered it, but I'm going to say one more time, it is going to increase innovation. So why we are doing automation? Because we would like to use the manual to the automation perspective. We would like to more collaborate that. So when you take out all these problems, communication problems, manual creations, rework, we are opening up a time for the engineers to innovate the software for better, analyzing, putting in new algorithms, using new techniques. So quality is becoming a sort of innovation in the engineers. Engineers are able to respond to needs because they have time to think about it. They are not really catching the work all the time. They're not working in the rework because rework is eliminated. So engineer has more time to write a better code to improve their knowledge, improving the system, because we are taking the nonsense, repetitive work from the engineers, we're opening a time. So if organization has a waterfall thinking of no DevOps, they were able to use only 25 to 30% of engineering time for coding. 60 to 70% of time is going either rework or in meetings. We have to change that. We have to change it, make sure that engineers is able to put the 70% of their time for coding and understanding and building new systems, less for the manual, less for the meetings. That's what we would like to do as a benefit of DevOps. So commonly question I have been asked, I think we covered up a little bit here, so I'm going to skip these sections. So takeaways of this session, make sure understanding DevOps is extension of agile thinking, right? Pre-existing hierarchies are workflows such as waterfall are rigid and slow, so we have to change that. And we have to really change our thinking, make sure that we're able to reduce any error by automating, and make sure our business is stable and quality. We have a feedbacking mechanisms. And DevOps has 4 principles: collaboration and infrastructure as a code, automation, and monitoring. So these 4 principles are important to us: organization element, infrastructure pieces, automation, and monitoring. Let's start to talk each of them separately. I'm going to start from the collaboration perspective, which is the communication perspective.
Hasan, shall we take a break, like 5 minutes or so? Are you okay?
Yeah, I'm fine. 5 minutes.
Yeah, okay. じゃあちょっとここで5分ほど休憩しまし
Okay,
ょう。
then we'd like to take a 5 minutes break.
体から支援を受けています。プラチナスポンサー、レジリエンスジャパン、ソナタイプ、データドック、レッドハット。ゴールドスポンサー、マイクロソフト、コグニティブリサーチラボ、Google クラウド。シルバースポンサー、ブレインパッド、HRD、プロファイルズ。講演、アメリカ大使館、カーネギーメロン大学ソフトウェアエンジニアリングインスティテュート、カーネギーメロン大学サイラボ、日本ディープラーニング協会、テンソルフローユーザーグループ東京、経済産業省。
Modern software applications consist of 90% open source components. These open source components often contain security issues. As we rely on open source software, companies have to reconsider their approach to security. Traditional manual processes based on whitelist and blacklist do not scale. They can really hold you back, especially when competitive advantage relies on speed of software delivery. That's why it's essential to build quality from the very beginning by adopting a shift-left mindset. Shift-left means integrating security practices early in the development lifecycle before your project reaches the finish line. Sonatype's platform helps you to automate open source governance early and everywhere in order to scale DevOps within your organization. Visit sonatype.com today for more information.
Because we've been this way from the start. Because a solution for one can be harnessed by others. Because clouds that compete can still connect. Because innovation needs collaboration. Because a revolutionary approach to software can transcend enterprise IT. Red Hat. Our code is open.
ビッグデータや AI 技術が脚光を浴びるデータの時代がやってきた。巨大企業もベンチャー企業もデータを大きな経営資源と捉えビジネスに取り入れようとしています。15年以上前からデータ活用の可能性をまっすぐに信じてきた私たち。今こそ一緒にデジタルトランスフォーメーションで開けるドアがたくさんあると思うのです。
持続可能な未来につながる扉、成長し続ける最適な意思決定、
データ分析の民主化、
顧客体験を磨き続ける世界、意味のある仕事を作る、
誰も想像できない
大きな成功、イントゥリアンの
製造の矛盾化、できたらいいなを形に、
仲間の笑顔が未来の笑顔を作る。
HRD グループは科学的なアプローチで人事や組織の改革を強力に支援しています。今、多くの企業がデジタルトランスフォーメーションに取り組んでいるのではないでしょうか。デジタルテクノロジーを活用することにより、営業やマーケティングの見直し、業務プロセスの自動化が様々な企業で実現されています。では、人材や組織に関してはどうでしょう。 一人一人の才能や個性に合わせた適材適所の実現や効果的なコミュニケーションの実践はデジタル化とは無縁の勘と経験に頼っているのが現状ではないでしょうか。このような勘と経験に頼ってきた人事や組織の課題もデータにより解決する時代になってきています。私たちの提供するディスクとプロファイル XT は科学的検証に裏打ちされた人材測定ツールです。一人一人のモチベーションの源泉やそのポテンシャルを見出すことで組織や人材の課題を解決します。全世界でこれまでに6000万人、10万社、日本でもこれまで120万人以上の顧客が効果を実感しているソリューションです。これからのデジタル時代の企業における改革の本質は、人と組織のトランスフォーメーションにあると私たちは考えています。HRD グループのディスクとプロファイル XT が組織や人材の改革を可能にします。効果的なコミュニケーションによる組織力向上に興味のある方はディスクで、社内の適材適所の実現や人材のポテンシャルを見出すことに興味のある方はプロファイル XT で検索して、ぜひ一度ホームページからお問い合わせください。DevSecOps Days 東京のコミュニティ活動は皆様からの支援で成り立っています。今後のコミュニティ活動への支援にご興味のある方はお気軽にご連絡ください。DevSecOps Days 東京は
So we're coming back. Okay, go ahead. 今、スポンサーの動画をちょっと見ていただきました。このコミュニティは、ですね。
This community is possible thanks to the sponsors. And we have simultaneous interpretation, and also we have the support from the sponsors. The speakers, in order to create the community, is making this available free of charge. So they're working as a volunteer. So distribution is, of course, costly. And for that part, we have a help of the sponsors. And also, how to expand this community, creating content is something that we are thinking about. In order to do so, I'd like to use this. So if you want to help this community, you're watching this today and you wanted to sponsor this, individuals or companies, please get in touch with me so we can work together so that we can promote the knowledge about the DevSecOps so that we can improve the competitiveness of Japanese companies and prepare ourselves for the cyber threats. So we'd like to create a kind of a culture. So I'd like to hand it back to Hasan-san.
Right, thank you, Yusuke. So let's continue. So we covered up the fundamentals. So I'm going to cover up the other, what we said at the principles at the beginning. I'm going to cover up in detail what are these principles are, what are these principles, how can we achieve these principles in detail. So the first one is the cultural piece. We talk about the communication. Let's talk about the communication. What does the communication means? What the importance of collaboration means in the software context. So as you see on the screen, the software project is a really complex mix of teams. It's not a dev team. And I know we're saying developers, but it's beyond that. So if you look at the screen like this, we have a scalability, we have infrastructure, maintenance, legal, data privacy. There are many stakeholders in building the systems. Maybe you not realize that it looks like a simple just building a web application. It's not. There's a business requirements, and there's a legality perspective. There are many organizations are paying a legal fee because of not addressing the compliance of the code. As I said at the beginning, if you are building a software that's going to run in Europe, you are compliant with the GDPR. You have to do the data privacy in your application. Who's going to govern that data privacy? Who's going to govern the compliance perspective? You need a legal team. You need a compliance team. You need a risk team as you're part of the software project. So when you really combine all together, this is the kind of like umbrella. Everybody's focusing their work as developer expertise business, but we would like them to collaborate. We would like them to share. Without collaboration of each of these components, issues we may see end of the process, maybe late after the game. I know we're talking about a security perspective, but we should not ignore the other components of the software that we are building. Legal is important, highly important. There are many use cases I can give you and how legal got paid a lot of money because of not applying the compliance perspective, not really giving enough attention of the software they're building should protect the privacy as an example. So we are responsible. And we are thinking developer knows everything. It's not. Developer has a zero idea about the data privacy. They have zero idea about the security. They have no idea about the legal perspective. How is that possible? We're expecting our developers building a system that meet our legal criteria or are the business criteria. So it's important to talk with each team members. The question is how? How can we talk that? So we remember that. I'm not going to go over agile thinking. So every transition we said, it is a risk. Remember the waterfall approach we said? Every time when we transition something to the other team, it's exposing a lot of risk in between. What the risks are. If you give a requirements in a written documents, if you define your system design it is, and your architect will understand what you give it to him as a requirements, or your developer will understand what the architecture is, they will try to interpret what architecture says in a design in their code based on their understanding. Because if they are siloed, if they're not communicating well each other's, we don't expect the same understanding of the code. That's the reason DevOps bring a team together, right? In other examples, development teams are more focused on the change. That's how it is the result of the DevOps movement. IT operation team are about the stabilities. That's their intent. That's their incentives. And security team is about the security perspective they're looking for. When we look at that, all these three components, we can expand more other stakeholders. Nobody is looking for the business need. It looks like we are, but in reality, we are not. So we have to change our mindset, our brain, and think about what is our business needs? What is our motivation? What is our vision that we are building the systems? As a team, we can get together. All right, how can we get together again? We are expecting all team members are continuously talking each other's. They are collaborating each other's. They are sharing what they learn each other's. Sharing is the one element. In the organization, please share your artifacts with others. Share artifacts means like don't send something to the 300 pages of document to your team members and say that I need a response by tomorrow. That's not practical. We have to find a way to share the information each other's. Either we can talk, like we are saying, heavy collaborations. You can talk, open up the communication channels in between. There are many ways to open up the communication channels with your team members. You can use chat applications. You can use wiki pages. You can use some platform. All the stakeholders can contribute. They can share their lesson, or they can give some information about their system, what they are doing it, or they can be aware of as a developer, you are building the systems. So remember, if you are sharing something and your team members will aware of what you are sharing, they know what you are working on. If you're a business owner, you're able to share your business constraints, your team know about it. If you are building a system, if you open up the legal channel for your dev team, legal channel should be part of the team not in their meetings, but somehow they're able to see what things are built, how they can advise the team members. So change the mindset of more sharing, more lesson learned. As a manager, don't really penalize the people what they are doing wrong as a dev team. Let them to learn from their mistakes. We are saying fast and learn, like let them expose what they learn and share the knowledge with other team members. Failing is okay, but failing is not okay if you're not able to fix on time. If you're not able to respond to failure, it's happening in production environment, that's the problem. We would like to go fast, but how to go fast is a team together. So change that culture mindset. Let's learn from our mistakes. Let's learn from our mistakes and share together. Let's ask the question for anything that we see in our infrastructure, in our development environments. Let's open up our communication mechanisms. Let's use the same collaboration environment. Being a culture, shareable culture is going to create two elements. One is the trust. If you share a lot with other team members, which will create a trust. Trust is important between each team members. How you gain the trust? Sharing the artifacts with them, being transparent with your team members. When you gain the trust each team members, then they know you're working for their work. You're not really looking for to penalize or criticize their work. You're looking for to work with them. Biggest barrier in the security world, security people, they don't trust the dev, they don't trust the security people. That's the reason we are having a lot of problems. We're not able to put security in our application because in the mindset, it looks like we are saying, yeah, we trust each other, but in the work, we don't. How can we gain the trust is the way of the communications, right? The way of the collaborate with the team members. As an example, in software development lifecycle, without the knowledge of the operation team, without knowledge of the systems, we may gonna decide by ourselves. In the lifecycle, there are many decision points in the lifecycle when we are building. Like an example, what type of operating system we are going to use? What type of port are we going to use? Are we going to use the SOAP? Are we going to use the ports? The firewall is enabled for us? What the scalability means? So if there is no questions not answered properly with the right stakeholders, let's say we're asking some questions, but other stakeholders, then they don't know, maybe we're not sharing, we're not asking. If we decide by ourselves, this is what is happening. If you let the developers do the work without talking other team members, we do a lot of zigzag. We will go and, if we are lucky, by the way, we can go to the end, finish up the product. That will take time, longer. It will take a longer time because we have a lot of zigzag. Zigzags, a lot of rework. We have to go back and change again, go to another one, go to another one. It's going to create a lot of zigzag, a lot of rework. So what we would like to do as a team, I know we said DevOps, but think about all the stakeholders together. We can go straight. Still, there will be some barriers in our journey. Still, there are some important decision points in the team, in some system they are building. If we work as a team to have a solution, we can go and fast as a team together. So that's the importance of the communication aspect of it. That's the importance of cultural aspect of it. So let's summarize what the basic we spoke so far, we covered up so far. We would like to really break down any confusion, any wall between the stakeholders. That's the first. Second, we would like to have a shared responsibility as a culture. We don't want to be blaming in each other. We have to have a same shared response because we are in the same organization. We're working with the same vision and same mission. That's the reason we would like to share either the success or the failure together. But we're going to learn from our failure. We're going to build up a learning culture, understanding, learning the problems. And very specific element for the security perspective, don't expect that your dev team knows security. I'm teaching a software security class at the CMU. Again, #1 CS in the US. My graduate students, they don't know the security. These are the master students. So what you're expecting that your developer understand the low-level vulnerabilities such as buffer overflow or integer overflow or string manipulations, it's difficult. They don't know because they learn how to write code better. They learn how to write code as the best algorithms. They know the techniques, how to write it, but they don't know what is the common vulnerabilities are. So building a culture to learn the knowledge, building up knowledge management system, and an example, you can build up a learning culture as a result of the learning from our mistakes. And lastly, we would like to have iterative incremental developments. That's what we would like to do, okay? Right, so I'm gonna go to the next topic about infrastructures in DevOps. So again, we covered up the first principle, so I'm gonna cover up the next 3 principles. Okay, infrastructure in DevOps. What are infrastructures? I'm sure audience, so you know the word infrastructure. I'm just gonna cover up a little bit at a high level. We're talking about the systems and networking that support the software development environment. So, which is your server room, your laptop, which I'm using right now, my monitor, my microphone, all together is infrastructure piece. Also, infrastructure has a switch in it, routers in it, and database and servers. And so we are covering up not just the hardware pieces, and all the software is also running infrastructure are part of the overall infrastructure perspective. In a typical deployment perspective, when you deploy any systems into the production environment, I am sure you have done it. Maybe some of you already doing it. So we are building a systems in a code in our laptops, in our desktops, whatever the environment we have. When we ship the code, a version into the production environment, we are planning the downtime. And when we plan the downtime, we pray. Not the deploying production, that's what we do. Still, we do that. Still, we are deploying any system to the production environment that we are scaling to do that. Like, I've been viewing some servers. I just checked that this morning, and I saw so much update for the Windows server. I was scared to restart the server because I don't know what will happen. Because we don't have a DevOps environment. I was helping one organization. They didn't build up a good mechanisms, deploy mechanisms, and wasn't able to advise it's going to work or not because they don't have a prep for the infrastructure perspective or a rollback perspective. So these are the deployment strategies are. To roll back the new features, it is requiring a complete infrastructure is in place. So I can do the rollback. So I wasn't able to advise that you can do as the operating system update because I don't know what will happen because they don't have a infrastructures in place. So that's one example. I'm sure they're the same thing. I'm sure you already know that Tuesdays, like Microsoft Tuesdays, you're getting a lot of updates on Tuesdays. Do you do every time? You're scaring most of the time because you don't want to get confusing any problems. So another traditional scenarios we do as an application development teams. So right now, when we build up a system, a very basic web application has a 3 tier, like a web tier and database tier in the bottom line, like the low-level tier. Like with the 3 tier applications, we combine together, putting everything into the one systems, which is our dev environment. In dev environment, a development environments, we have a database, DB server. We have an application running on a web server, like a Tomcat Apache as a web server. You may have IISS, another server from Microsoft. You may have an NGINX, whatever the service you have, you can build up web servers, and then you're using a server environment. So that's kind of a scenarios in dev environments. When you build as a developer on this environment, when you ship to a team is basically the production team, and what they do, following the manual installations. Like why we like the other deployments for our phone that we're using it, like our phone as an example. Because it's automated, because it's not requiring any manual installation. So we can go back quickly. If something happens, we can go to the previous version. Why don't we have the same mindset in our infrastructures? Instead of having a manual configuration, manual component to the server room, it's old. We cannot use it anymore. We have to change that. This is the typical traditional scenarios. When you do that, we see a lot of manual problems. I'm going to share a couple examples how much time people are spending in a complex systems and deploying into a production environment with the manual steps. There was a question at the beginning. I'm going to reference that questions. Why we cannot apply, or it's difficult to apply the systems? Because we are doing a lot of manual installations. This is the way we can use DevSecOps for the software intensive or the systems or the hardware systems. We can automate that. What we are doing, we are starting from the bottom up. We talk about the culture. We are talking about what can we do as automation. Infrastructure is where we start. Another important factor on the deployment integration perspective. So every environment, when we build up the systems, we are building the systems in our development environments as a developer we use. We are handing over the system for the test team, and testers are testing the systems. If we don't have a same environment means the same characteristics of environment, same operating systems, same configuration, same port in terms of the accessibilities, and then same hierarchy of the servers. If you don't have it, services, then every environment will diverge from each other's. When it diverge, then you may have a lot of integration problem. Like starting from dev team, it's changing a little bit in test, changing in staging, and your dev team, it's becoming a different version of your production environment. So if it is a different version, as in terms of dependencies, a configuration, operating system needs, even the version of operating systems, then your system is not going to work out. Like, if you find
Hasan, can I cut in now? And
yes,
there is last week we had a incident in Japan. The Tokyo Stock Exchange closed for a day, and then the reason is actually based on this. So I want to explain this in Japanese from now on.
Please.
まさにここ今ハサンさん話してくれるとこ。
Hasan was discussing a very important point. Just last week, Tokyo Security Exchange, TSE, suspended its operations, and they could not even start the operation and transaction. The details is not yet known, but as far as we are informed, the system that was working, or there was an environment in which systems 1 and 2 were functioning, and usually system was in charge and system 2 takes over should an incident occur. And there was supposed to be a backup in terms of the incident, but system 1 didn't work, and then they tried to switch to system 2, but system 1 and 2 were not identical. That is why they realized immediately before the opening of the morning market that they cannot be switched over to system number 2. And that was why they had to suspend the transaction for the entire day. So this was really a result of the waterfall thinking or waterfall infrastructure stacking systems. And this is the problem that was quite typical of this waterfall hierarchy. So that is why this DevOps or DevSecOps arrangement is in need, so that the Tokyo Stock Exchange doesn't have to have the same issue again. So Fujitsu must be working very hard on it, and then the solution, one of the solutions can be found in the lectures that is to come up later today and tomorrow. And I think that this is a very relevant topic for the Japanese audience.
Over to you, Hasan.
Okay, thank you so much, Yusuke. I'm sure you gave an example. There are many examples we can give in that topic, so it's really important. So the first one is a set scenario is like we find something production and we cannot reproduce in the environment, even though we cannot roll back the production environment because we don't know what the artifacts are. Here is another example, and it's maybe similar things what Yusuke said. Like in organization, this is a real example. An organization is not able to find the errors in the system integration lab or hardware lab. It was unique to the different environments. There is no way for them to find out an example of which one is running, which is the right version, which component has been used, what type of dependencies are. So there are many questions. It goes back to a dumpster fire I showed at the beginning. That was the reason. This is one of the example of dumpster fire component. Like it's not working because of there is the different configurations. Because of it's not using all manual. It's all the configurations are manual that we're using in the systems. it is causing some problems. Let's look at the scenario 2. In the scenario 2, another example, so production environment, so we are building the environment based on what the developer says to us, right? When the developer is building the manifestos and log documents, you have to this, you have to that, you have to this, you have to do that. And sometimes developer may change the one of the steps, maybe incorrect version of the package, maybe incorrect steps. If you have hundreds of services is running, if you know what each service dependencies are, if it is manual step, and you cannot really create that all the service as one at a time. It will take time. Manually, you cannot type all the service together. So another example, in the manual build, which is a complex system. That's the reason Department of Defense, DoD, wants to go to DevSecOps, because they would like to eliminate manual installation, manual configuration. One example from the DoD program, they were using 8,000 pages of installation instruction, 8,000 pages. For just install a system as up and running takes more than 180 days. 180 days, just manual step and building configurations. But that can be solved easily. Right? So that's one of the examples. Another one is code is perfectly working fine. Developer says it's working great. What can I do for you? If it's not working production, it says that's not my problem anymore. It is your problem as the IT persons. I am sure one of you as an IT person, I am sure you heard that, right? You found something in the production environment, some of the database not responding on time. Maybe there's a latency is happening. You ask the developer says, I did my job. It's working perfectly fine in my environment. I'm sure you heard it because we are using a different system, different configurations, which is we will talk about the parity. I'm going to skip the parity. And eventually that program, by the way, completely terminated because they're not able to do manual steps. It was all days, they couldn't do it. So last one as a scenario, when we have a new hire to our project teams, we always spend a lot of time with engineers configuring the laptop, configuring the systems, make sure the person is able to contribute to the code, because we are creating a so much dependent environment that even the engineers we hired, person not able to promote or not able to write the code in day number 1. We are paying a lot of money to the engineers, but we are not able to do it effectively. Why? Because we have a manual configuration. Why? We have all configurations components are different than each other's, because we don't have a code running somewhere else. So we don't have infrastructure as a code. That's what IAC means. That's a solution. So what is IAC? Infrastructure as a code. This is very, very important. When we say infrastructure as a code, it's a program that creates the infrastructure, depends on your virtualization environments, depends on your hardware stack, even though you can really configure every layers in your data server infrastructure, starting from the switch layer all the way back to the application layer. Like you can configure the switch manually, but we don't want to configure the switch manually. We would like to configure the switch as automated script through a CLI interface. You can push that. Or you can create a network configuration virtual VLAN on your switch as an example. Or you can create a script, provision your hardware, your server from Pixibot as an example. So starting from that layer, including virtualization, that you can virtualize your environment. You can use a VirtualBox, ESXi server, or the VMware workstations, or a cloud environment, or EC2 instance, name it. Every virtualization is capable to use as a code. Once we create an infrastructure from the code base, then we can deploy the application-related code on top of it. So now we are not saying that just the infrastructure right now. We are talking about the configuration element of the applications. So we exactly know what type of application is dependent we are putting into the system. So as a result, our system will be identical during the test, during the staging, or production, or each team members are using the same version of environments, dev, test, and staging, production. at the same time, we are able to push the new configuration, the same configuration, and everybody will have that. Then putting everything into our repository is important. Repositories are the source code repos, like GitHub, like GitLab, like a stash, whatever the infrastructure, whatever the repository you're using it, you can put all the IAC code into your repository management. That's what IAC means. This is a quick example, which is very familiar to you. This is one example like using a bash script. So instead of writing manual instructions in your documents, put that manual instruction, creating a little bash script, then you can create a code for you, which is very basic. You can start. See, it's the mindset changes. Instead of saying do this and do this, put everything into the bash script and then put into the repositories. So you have exactly how we are getting the libraries from where. Maybe like you're cloning the code, which is right here. You're using a certain JDK libraries, 7 as an example. You're using a Tomcat 7 as an example. You're using the version already in the code. When you run this code, there's a steps like you're deploying the code Tomcat, you're running the code as a Maven package as an example here. So basically you're creating infrastructures, then you are putting dependencies in your code and pulling from your common repositories and run it. So when you look at this example, you can exactly know which version that we are installing, where we are installing, what is the order of that installation that we are running on it. So the good things about in this type of write-ups, either it's going to work or not. If there's a dependency problem, it's going to stop the work. When you try to update any dependencies, then you just go and change one place in your code, which is IAC code in your repositories, and every server will have the same code. So what IAC does typically, it creates the VM and provision the virtual machine. VM is the virtual machine on the physical hardware specific dependencies. So it's not creating hardware yet. From the hardware layer to always to the application layer does the IAC code perspective. Okay, that's what IAC means, what the infrastructure means. So a couple of benefits. As we said, it's going to create a master version of the environments. We can put the versioning of environments very easily, right? So when you deploy the code into your production environment, remember, the code we are building has other dependencies together. Dependencies are third-party libraries, configurations, the server requirements. So each of the version, then you can create a version which your code together running a production environment. If something happened in the version 3, you can go to version 2 as an example, which you can roll back. When you roll back application, you need to roll back all the environment configuration together. So rolling back to the previous version of is not going to work out. You have to roll back the previous version of the dependencies as well. You have to revert back to the operating system changes if you have it. So to do that, it is requiring the IAC creations. So there are many examples, like using a CloudFormation template is another example for IAC, which is AWS component. If you are familiar with AWS as an example, you can create a VPCs, virtual private the networks, VPN. You can create a virtual private gateways, or you can create a switch. You can create a virtual switch. You can do all the network configuration on AWS as the CloudFormation template, as scripted. You can use that code. That can be a Ruby code or whatever the code you're writing it, the Python code. You can create a whole infrastructure, a line of code as an example. You can do everything from scratch very easily with the code perspective. So code will run all the time. If there's a problem, you will see the problem. In the manual, it will take time to type it together. So the couple security perspective, it is really promoting collaboration. Remember, we said we would like to collaborate with other team members. How can we collaborate? Here is an example you can collaborate. As a dev team, write all your dependencies in your code as the script, share it with your security teams. So security will know exactly what type of dependencies are using it. It's a trust right here. If your security team knows all your build scripts, all your dependencies, And then they know your code is running on what our dependencies are. They can vet it for you. They can approve the dependencies for you. So it's very important for the security perspective as well. Remember, I showed an example. We would like to know which version of the dependency are running, like a Tomcat Apache as an example. There's actually a good story I can tell you here. And there was a Equifax the breach in the US a couple of years ago. There was a Tomcat Apache Stratus vulnerabilities on one of the production servers in Equifax, which is a credit card company. It took them 3 months to patch it. The couple of reasons behind the scene: either they don't know where the libraries are dependent, which is Tomcat Apache, didn't have a mechanisms to patch on time, which is automation perspective. So 2 elements, they didn't have it in place, they couldn't patch on time. When you cannot patch any vulnerabilities in your production environment on time, it is becoming a 0-day vulnerability for you. What the 0-day means, adversaries will take an advantage of the vulnerabilities has been advertised on the CV's or CW's website on the market. If you don't, as a company, if you don't patch that vulnerabilities, you are becoming a vulnerable for the adversaries. What adversaries will do, they can scan your, as the web servers or your systems, looking for which version you're using, which is the first steps in the pen testing about reconnaissance. Maybe you're familiar. Reconnaissance means understand the systems. What understand the system means what the versions are. Why adversaries are looking for the versions? Because they know exactly what the available vulnerabilities are in that version. As soon as when they know the version that you're running in your infrastructures, your operating systems, your web services, they will try to tackle by knowing vulnerabilities. So connect that requirements to your infrastructure. If you have an automation infrastructure, then you can easily deploy the new versions. So there are quality attributes in IAC perspective, which is automatable. We can automate every manual steps. Now it is automated. We can write anytime. We can repeat as much as we can, right? We can look at a different version. We can diff it because it's a basically text. It's a code. We can compare what has been changed, who changed it, when they change it. It is human readable. It's versionable. So it's great to have an IAC concept in your code. So I always teach my students, I'll say, when you write any steps for installing a very basic VM with the Tomcat Apache as an example with the one sample project, write all the steps first manually, and then try to convert your steps into the code and give me the code for me. So that's where you start. When they start to really write the code from the steps, they realize that they miss a lot of things, such as version, such as the dependencies, such as order of operations. They miss that. So now, basically, I'm verifying what they wrote as the steps for the installation, for the configuration, for the whatever their job it is. And then when they convert into the script, which is a bash script, .sh, or can be a Vagrant file, or can be a Docker file, whatever the file they're creating, so they can put all the steps into the configuration items, and as the instructor or the friend, I can just run it. So it is just repeatable and automated. I'm not really looking for the steps. I'm just running the one line of the code. It is standing up an environment for me. And which is kind of like we cover up all the security benefits already, which it's fast onboarding, stables, and value guaranteed documentation, etc. So as the common tools, shell script, one example, which we can use. The Vagrant, Chef, or Puppet, these are typical examples that we can use. I'm just going to pause here and share my screen to show you an example of the code. Bear with me. So I would like to show the code, how it is, how this looks like. And sharing. And bear with me. Visual Studio Code. So this is one example, like on the screen, you see that I'm writing everything in one single file, which is Vagrant file, creating a virtual machine for me. Once create a virtual machine, it's creating a network configurations right here. If I can make it a little bit bigger. Right, Control plus. All right, I'm sure it's visible now. So as you can see, like it's creating a version with a private network, installing Ubuntu, and having all the configurations for me, which is the typical configuration, and then installing the basic SonarQube, this is basically building a pipeline, building a DevSecOps environment for me. As you can see on the screen, every version is traceable. I can look at this code, I can grab it here, configure it, it's automated. Then creating a configuration file. This is my configuration file for the Jenkins. So basically getting one configuration file, which is this one is a Jenkins, and configure the Jenkins server from the code itself. So there is no manual configuration. Automatically, this code will run it for me. And then configure it, and then the code build, and then push the code itself. So this is one example. Or there's another example, which is a Vagrant file. This is another example for the shell script. So basically creating a manual installation switch with a manual on the command line. This will help me to configure it directly from the shell script. This is a provision as an example. I created a shell script. I deployed now. It's another example of creating a shell script and running from the command line and installing the Jenkins as an example. Configuring the plugins as an example. See that? This is basically configuring all the plugins in the Jenkins environment, which is building the same thing. So I know exactly which version it is. Quick example. Same thing, building a SonarQube. Here is the version right there. So these are the couple of examples will help you to understand the dependencies to use that. This is one example from the pet clinic. There are many examples I can present, but I don't have enough time. So short story, you can write so many code as a code itself and share it with your team members. That's how we can achieve the infrastructure as a code and writing. Again, this is, we do all the time as a developers. We do all the time as the IT team. Using a chef recipes and chef cookbooks will help us to build up an environment quickly. That's what specifically what the environment is. Okay, let's go back to the slide again. All right, so I'm sure you got some ideas about the code. All right, let's continue. So important to remember from the infrastructure as a code, environment parity throughout the development environment is important. And we would like to develop and treat provisioning script as part of our code repository. So code is not just writing a code. Code should have other elements as well in place. So I'm going to cover up a little bit about containers and VM. I'm just going to go quickly. This is very important fact. You should understand what the containerization means, what the virtual machine it is. So a lot of people like to talk about the tech talks, right? Everybody's talking about containers and Kubernetes. It's an example from Dilbert Catalog. I like the Dilbert what it says. It's a techie things, but you cannot solve a problem just by saying techie things. We should understand that. It's always nice to talk about the very high level term, but we have to understand what it is. We have to understand what the containers it is. What is the purpose about it? So we can really see why we are using, what is the reason to using a Docker container as an example. So what is the real containers? Container is a standard unit of software. It's packaging up all the dependencies, libraries in an environment together and then putting into either production or different environments. So container as a result of implementation infrastructure as a code is another example. So it's basically implementing IAC with a Docker file, which is a container file, put all the dependencies in the application context and service context, packaging together. So you have basically, as the dependencies are in the same file, you can put into the containers are working in the containers application. It's going to give you a portability perspective. It's going to give you easy to run different operating systems and different platform as well. Makes very easy to standardize your development environment or operation environment as well. So comparing the VM virtual machines and containers, so virtual machine is running in the hardware, and this is basically a hardware piece like either laptop or a server, and then virtual machine is a hypervisor running either ESXi server or using your operating system, Windows hypervisor. Each of the VM has its own operating systems, right here, like a green and yellow and red. So each VM has its own operating systems. each VM virtual machine has the libraries and app is running on it, which is kind of like a replica of your laptops and server, whatever the infrastructure you have, creating a virtualized version of it. However, containers is using a common libraries or common operating systems, just focusing on the application and dependencies only, just focusing only for app version. Let's say you have an Ubuntu systems, right? Your applications running in Ubuntu, but different version of application require different of dependencies. App 1 has a different dependencies, App 2 has a different dependencies, but 3 systems are using the same operating systems. This is a perfect example in using a container for the same operating systems, but different dependencies. That's the reason Docker is becoming very powerful and packaged all the dependency libraries together with app specific and deployed. But we cannot put everything in the containers. Containers should be very lightweight because we would like to go fast. So I don't want to, just basic comparison between the VM and containers. Each VM is operating system, which I already said before. Each VM has operating systems and IP addresses, but the containers are using a same operating systems. So what is really bringing to us having a containerization perspective? It's bringing us for the containers portables. We can really share the VMs with different platforms and different operating systems. It's very easy to use that. So IAC concept, if you want to standardize your dev environments with the operation and then test and staging, this is one example for you. As a developer, put all the dependencies in a Docker file. You share the same Docker file with your test team, with your operation team, so they will have the same dependencies for you. So VM and VM also, the container can be the same environment under the same virtual machines and using the same hardware. It's perfectly fine. Depends on use case, you can do that. So there are a couple trade-offs between the VMs and then between the containers. And virtual machines give you more freedom to choose, and containers are lightweight. So if you have a full control of your operating systems and your networking, VM is great. But if you're looking for a very lightweight and with the limited networking features, container is a perfect solution. Because container takes a shorter time to run. If you run any containers, it takes a couple seconds versus VM takes maybe a couple minutes, maybe 10 minutes, depends on the size of the VM. But in the container, you're going to make sure that your container has been laid properly. Like you cannot put a very bulky dependencies in your containers. You should have a very layered approach when you create a container. When I say the layer, put your dependencies. Let's say you have one layer just to the web services, Tomcat Apache. Another layer does application on top of it. So creating a layer architecture, speed up your deployment perspective. Because maybe other containers are using the same Tomcat Apache. So once you deploy it, the next time you deploy the new version, you're basically deploying only the change version. And that's really much easier and much faster, push the new version for operating to your production environment. So I'm going to go to the next topic as part of the IAC, which is deployment pipeline. So everybody's talking about the DevSecOps as the tooling perspective, like it's a pipeline that includes automated procedures, enable collaboration, risk, security, and that system is building the business units. So basically a platform, DevSecOps platform that enables the infrastructure piece, that enables the communication piece, automation perspective. However, building up DevSecOps environment is very challenging. So when we say DevSecOps environment, again, it's not we can buy somewhere else. We had to build up something based on our needs, based on our technical needs, based on our organizational needs, based on the tools we are using it. So there are many tools available in the market. There are many tools. And the number is increasing, by the way. It's not 180 anymore. It may be more than 200 already right now. So if you look at that, I'm going to go each of them. There is a reason, if you're looking for the source code repositories, you should have a specific source code, issue tracking system, containers, a server, software tool for testing framework, release configuration, configuration management. There are many, many components. But how can we select the right tools to build up our DevSecOps environment, because if you would like to go fast, if you would like to automate the process, it is really requiring a good infrastructures in place, good tools in place, integrated tool in place. So engineering pipeline is really challenging. If you're not able to engineer a pipeline properly, and you cannot deploy a system quickly, you cannot really take any type of metrics from your pipeline, right? So whether you're designing or buying, you have to understand end-to-end requirements of your system that you're building. Remember, our goal go fast. Our goal go really speed. We would like to eliminate and rework, but that all depends on our DevSecOps infrastructures. That all depends on tool we are using, right? So when you pick any tools in your deployment pipeline, in your DevSecOps environment, there are some quality attributes. I wish we were in person, we can discuss longer. It's really heart of the building pipeline concept, but I'm just gonna cover up high level. Just ask yourself in your organization, these are the key quality attributes. If I were to take the screenshot from YouTube, somewhere else, know that this is very important to select any tools when you are in a position to buying some tools into your software delivery pipeline. Like make sure you're able to integrate the tools with other tools. Make sure your tool is usable, you're buying it. Make sure it's secure. So each of them is really a long topic to cover up, but end of the goal, pick the tools should be integrated, should be automated, and should able to give you as the integration component. So we don't want to create a tools or buying a tools, that tool is forcing us to be a siloed. When I say siloed, remember at the beginning we said we would like to break the silos between the dev team and architect team and testers and other folks. If you are getting a tools, if your tool is not talking other tools, and your tool is forcing you to be a silo, your tools is really creating a completely closed environment which you cannot share. Remember the cultural organization perspective said we would like to share. If we cannot really get some report from the tools, how you expect that you're going to share some artifact with your other team members? See, that tool is becoming a barrier for you. It's supposed to be enabler, it's becoming a barrier for you. So as a one model, I would like to propose, I teach always my class, keep all the components into your source control right here, and then make sure you're building other must-have component. This is the minimal viable product as building your DevSecOps environment. You should have a source control in the centralized in your pipeline. Source control should be able to talk with your monitoring systems, your communication system like a chat applications, your issue tracking system such as the Jira or the Redmine or the GitLab or GitHub, whatever issue track system are using it. And your build systems should communicate each other. So a lot of organizations are building the build server, CI, and putting just a source control here. It is not a DevSecOps. It's not a DevOps either. You just have a very basic, very minimal, I don't want to say minimal actually, very basic version of just having a CI and a source control is not practical. It's not a DevSecOps. We would like to integrate all of it. We would like to integrate with issue tracking system. We would like to integrate, let's go back. We would like to integrate with the documentation system, code review. So all this combination together will help us to build up a DevSecOps environment. So one example is an exemplar DevSecOps platform. See that this is the engine pieces should be connected. Continuous integration, code review. These are the components should go automatically. We would like to make sure CI/CD, continuous integration, continuous deployment delivery is the automation engine of the DevSecOps. Your tools that you're selecting should integrate with each other. If you are building up a hardware component, there is a virtualization of the hardware pieces as an example on the screen. So pick the tools based on your needs. Don't buy the tools, then change your architecture. It's a bad attitude. That's one of the challenge. Remember, one of the questions was about the challenge, because we usually buy something and we are trying to change our organization. It's very difficult. Look at your organization needs, buy something that you can connect the dots. And then you can use the monitoring element on top of it. You can use the other application-related life cycles on top of it. So I will cover up more in details, but start from the hardware layer. You can use the virtualization and using the operating system layers, and then going back to the screen so you can use other components as well. So all this combination can be as an IAC. You can use infrastructure as a code to build up the infrastructure, at the same time build up the code itself and monitoring. So monitoring piece is right here. So if you would like to collect data, every phase of life cycle, monitor that. So why is it important for us? As a so far, if you do the DevSecOps properly, and you are doing automation more than the human. So just positive, think about in a second. As a human, we are as a designer, engineer, or the product or the lead, we are creating the code. We are putting our brain into it. Let the system handle all the automations, issue tracking system, repository management, build server, documentation server, all this component should automatically done from the system. As a human, we would like to just generate the input for the software development process. Inputs are writing the code. Inputs are putting the compliances. Inputs are putting the requirements. So as a human, just do what you're supposed to do. Don't do the repetitive steps, manual steps over and over and again. Let the system handle behind the scene as fully automations. Automate the integration and deployment, build and test cases so we can build up automation perspective and then feeding back to the result to the human so human can see what is going on, like the artifacts, like the metrics, like documentation, like the internal documentation, like the status, like the chat. So these are the mechanisms you can use the artifacts from the pipeline and sending to the human for their analyzing, for understanding systems. So important points to remember, we would like to establish integrated development pipeline. Again, we don't want to create a pipeline as siloed. We would like to have integrated development pipeline. That means tools are talking each other. Right? And have a standardization within the same program. We don't want to have multiple programs working each other. There's a couple of things like open source usage, which is in the security component I will cover up, and make sure you have design and develop deployment pipeline upfront. Understand your needs and look at the tooling to understand, to improve, to applicable to you for your program and for your systems. It's important to pick that. Like, don't pick the tools. It's not going to work in the Windows environment that you would like a Windows development environment. Or if you are using if your code, everything is Linux-based, pick the Linux-based tool. So make sure that your code, your architect will be enabled from your DevSecOps environment. Should not be a barrier for you. Right. So now we're going to go to automation perspective.
Hasan, we get some questions from audience, please. And they start to chat each other now. And one question is what is the advantage of VM to container?
So there's only one advantage of the VM in container. If you want to have a full control of the operating systems configurations, like if you're looking for a system as the hardware you're controlling and as the management that component, VM is great. Like fully manageable as like a server or like a machine, like a physical bare metal machine. VM is okay for that perspective. That's only benefits I can say, Yusuke. There is no other benefits.
Yep. So other question from the audience is when you containerize you don't have to think about the hardware, but why Docker on Mac is pretty heavy than other OS?
So let's separate this Docker example. There is an engine running behind the scene. Engine is giving a hypervisor. Let me go back to my container slide. I can clearly explain here. So in the container runtime, this is the engine. So Docker engine is running here, giving a hypervisor. It is true the Mac is a little bit heavier than the Linux because Mac has its own, like the container hypervisor, Docker engines, creating interface between host operating systems with the container itself. So each container file are the same. It's not changing either Linux or Mac or Windows. Only the engine pieces are different because engine is giving a hypervisor communication between operating systems and the container. So Mac has a different type of security constraints, different of hierarchy, and Docker engine is running based on what the Mac requirements, but it's not affecting to you. If you look at, so I really advise, don't really focus about the Docker engine, look at the Docker files. So when you create Docker files, make sure that your file is using a base image and layered approach. So you can create a Docker container, Docker file, we can put everything into it. It's not a good practice. So you should think about what my app needs, what does the app configuration are, what my dependencies are, create as much as layer as possible, and use that container for each of the layers. So you can have in your Docker file, you can create a base image called another base image. So every time when you update the new image, it just updates the required one. It's not going to update everything else. So two part of that, your question. Don't focus on the Docker engine. Look at for the Docker files as an example. Docker file is the same for either running on an Amazon Fargate or Amazon ECS or the Azure environment or Google. It doesn't really matter. So engine is hosted on an environment. Right? I hope that cleared up the questions.
Yep. So we have 30 more minutes to go. And do you want to take a break or you want to go through?
That's okay. I would like to finish up in 30 minutes. I'm perfectly fine. And I would like to cover up the continuous integration, continuous deployment, Yusuke. It's important. So we cannot finish up everything today, but it's a great discussion, great talk so far. I really enjoyed that.
Yep.
I wish we have more time to talk in person. Let me finish up the continuous security, the continuous integration, and then touch the takeaways.
Sure.
So, right.
Go ahead.
Okay. So automation perspective. So automation is the continuous integration, continuous delivery, right? So we would like to automate that. The first step is automation, start from integration. Integration is challenging because we do a lot of manual integration. When you have a different developers, developer A, B, or different team members, when we try to integrate that manually, it's creating a lot of problem for us. Manual integration about the conflicts. I was doing 20 years ago. It was very challenging for me building the code, another person's building code. We build up a machine, another dedicated desktops, and we're able to get the code. Even though we're using a source like Microsoft Visual Source Safe, or anybody remember the source safe was old. There is on that kind of like a locking mechanism. It's not a source code repository anyway, like kind of locking mechanisms. We're just building the code in one machine as dedicated for the build purpose because there are a lot of configurations happening manually. It's often manual process. So look at this example here. When we build up the code, so we are building the code, project team is including everybody else. Remember, we're not talking dev team anymore. Project teams consist of other stakeholders, your operation team, your security teams, your test team. So basically all these people are doing manually, putting into repositories, and then the build server, build and test and deploy, everything is manual process. So we like to automate as much as possible. We have to change this picture to make it automated possible. So let's continue. The manual integration it's the human-driven process. It's infrequent, inexpensive, and repetitive because we manually configure each of the steps. We manually look at the conflict in the code base, and we're looking for what type of problem we may see, and vitamin is one of them. We can automate that when we automate the code, removing any inefficiencies in the human-driven environment. We guarantee that consistent result all the time. We allow team to fail fast and fix fast because that's another important for us for automation perspective. Right? We will automate that. When we automate, we can find any human-driven process early error in our build process. When we do the continuous integration, now we're using a server to build the code every changes. Remember at the beginning I said, we would like to integrate every day. To integrate every day of the code that we are building, requiring a continuous integration. Now we are saying every change. So think about integration perspective, if you're able to integrate the code in every change, then creating any type of errors as a build result, that will be notified to the users as early as build result, maybe at 10 minutes, maybe a day. So think about the reward. If you discover any failure in continuous integration, which is a day, your reward will be maybe only a full day of effort. That's worst case scenario, because if you do the continuous integration. So you're able to catch the error a day later. If you are building integration 2 weeks, your reward will be at 2 weeks. If you are building the code a 6-month cycle, your reward may be a 6 month. That's how important to use the continuous integration as early as possible in every change. So like an organization building the continuous integration, and then when they build a break, putting into the message into the chat window, immediately people are notified there is a problem in the build, let's go fix it. So we have to have a feedback on time. That's how we're getting a feedback from our systems and feeding back to the team members on immediate for any reactions they can do. And other things we can do in the continuous integration, we can enforce any standards. So we can, for instance, standard means like looking for the security perspective. We can put the compliance perspective. We can put the risk into the continuous integration. We can enforce any policies, not building the code. We can do the test coverage. We can other components. So we make sure that our standard is in place. So overall, what is continuous integration? It's the process that continually merges system artifacts. It is not just the source code. It is all artifacts and then shared artifacts with all stakeholders on time and share the result. Remember, we said about the communication and collaboration. That's the way how can we communicate and collaborate. That's the way how can we share the result other team members. So now, how we achieve the cultural, we need a tool to achieve the cultures. So like we are using the tools to help us. We're using the mindset for integration to help the team members to share the artifacts. So now we are sharing all the artifacts, all the stakeholders about the system that we are building. So as a summary, this is your continuous integration model. So we would like to really build automated testing and deploy, and everything should be automated. Should not be any manual process, including the code, including infrastructure code, including documentation as well. And I saw that many organizations are doing very good DevOps. They were able to create the user manuals directly from the build steps. They were able to create any type of a versioning of the code as the same artifacts that they're building. As soon as when they release the code to their customers, automatically the code also generates the documents. They're using user guide as a parallel together. I am sure how many times you find that we have a version of application, but your user guide is not reflecting the true statements, maybe old versions. It's not up to date because they're not really treating the documentation as part of the system they're building. Two things important here. Remember I said at the beginning, if you cannot roll back to the previous version of the code in your production environment, you cannot be resilient because you have other dependencies. So because when we build the code, we are not adding the other artifacts as package of the build together, like infrastructure configuration, like security configurations, like the server configurations. So we have to create a package, the code, not just the code, all the artifacts together and label it and deploy into the production environment. So fail the build when software is not good enough. Don't really configure the fail for just compile and build error. This is bad. Like the first one, which we do, when our code is built, we are seeing it's perfectly fine. You do already in your dev environment. Don't do just finding build errors. That's not intent. Intent of continuous integration, merge it, do the test, and then do other compliance perspective, and release any type of errors, either compilation error or test cases, immediately with the stakeholders. That's the important elements of continuous integration. As I said, CI is the best tool to enforce any type of quality standards, including security. Right? So continuous integration really requires some discipline. Remember at the beginning, I said, you need to have a process and practices. This is the way you can enforce the policies and practices for your continuous integration. Continuous integration cannot happen by itself. If your developers are not committing the code into the repository environment at daily or any changes, how you expect that system is going to build on every change? If your developer is not putting the code a day, maybe putting a code into repositories, committing code in 2 weeks later, you're not doing this continuous integration. You're doing something continuous sprint, maybe, whatever you call. So it is every commit should be done on a daily basis. And other elements on the continuous integration, we have to commit the code with the configuration or with a case number in it. So we have a fully automated and traceable back to our repositories. Remember we said repository management with issue tracking. So if your build is failed because of test reason, we should be able to trace back to the requirements from our repositories all the way back to the issue tracking system that you can do from the continuous integration. And another things to make sure effectively, we have to automate every steps of the build process. Right? If your build process is not automated, you cannot take an advantage of continuous integration. You have to make sure that how can you automate your build steps. You should not have any manual interaction. Maybe you have to write some glue code. That's perfectly fine. Remember, if you are doing a manual steps twice, then you definitely gonna make the manual steps third time as usage. So as an advice to you, if you are doing any manual step more than twice, think about automations, because you definitely need a third time. You write a script, put some glue code. Whatever the code you're writing, think about from automation perspective. It's the heart of the DevSecOps. It's heart of the continuous integration. Okay? It is heart of the continuous deployment. And lastly, all environments should be 100% parity, which we learned that how can with environment parity using a IAC or using a Dockerized version of it. So environment should be the same configuration with the dev staging and testing environment. So there are many rewards as the advantage. It's a little lower cost for any type of problems, which is lowering the cost. We don't want to be getting errors in 6 months later. Remember the cycle we showed at the beginning? We would like to fix the problem as early as close to the requirements, close to the development phase. So CI will help you to capture any type of errors as early as possible. When you expose the report from your CI server to the team members, then team members will address immediately, because you are creating a visibilities. You are transparent right now. So transparent means like you're not saying as a word. Now your CI server sharing the result of the test cases to all the stakeholders. Even your customers, and some organizations are really creating a staging-like environment. It's not a production, and some sort of a place. As soon as when they build the code and put into the user test cases or the staging environment, your customer will see as a beta version. And they can take a look. They can give more feedback before you. And lastly, it's going to create a very high confidence in your software environment because of your building many times. So there are a couple integration systems, CI systems available in the market. There are many of them, Jenkins, Bamboo, GoCD. There's many things available right now. Really pick the continuous integration server based on your needs. So I'm not going to advise one is better than the other. All of them are doing a great capabilities, but really pick the continuous integration server based on your technical stacks. If you're in a greenfield, and ask your team members. Again, somebody has to maintain the CI server. Somebody has to maintain how it is going to work out. I wish we have time. I can make a quick demo for Jenkins. Maybe I can at the end. But they literally and look for what is your needs and what the capabilities you are, what your build steps are. You can pick the continuous integration server. So a couple notes to remember. We would like to integrate as early as possible. and we have to build and deliver the code continuously. Again, not just the code, we would like to build up other artifacts. We would like to document infrastructure code, documents with test result. Everything should be part of our continuous integrations. And then we have to really put the test automation into the build process. Again, building, not just finding the build errors. We would like to test. We would like that test cases. How much you can do the test, your system become more resilient. Resilience is about the system quality. Resilience is about how the system is going to behave in your production environment. The first steps, do more testing, more test automation. To do test automation, you have to build up IAC. To do the better IAC, you have to build up infrastructure piece. To do build up all this component, you need a human, you need a good culture to work in the same environment or sharing the artifacts together. So I'm going to continue the next step about the continuous perspective. So we're going to cover up the continuous delivery deployment and continuous monitoring. These are the automation perspective. All right. So I'm going to clarify the two terms. A continuous deployment is automated process for deploying any changes to production environment. A continuous delivery is doing the same thing to the staging environment or a manual steps into the production environment. But deployment is automated process. So we are building the code as the CI server. From CI server, continuous integration server, to the production environment happens only two ways. Either continuous deployment automatically goes from the CI server to the production environment automatically, or continuous delivery, we can deploy to the staging as automatically, but to production is manual steps. That's what the deployment delivery means. So what is really the continuous deployment reason? It depends on your business case. You don't need to have a continuous deployment if you don't need to change, like don't change something for the sake of change. You should have a reason to have a continuous deployment. That really depends on your business needs, depends on your organization needs, depends on your market needs. So you can define your deployment strategies. That's kind of little engineering component here. You can define your strategies based on what you need to achieve in your organizations. So having a continuous delivery, we are shifting the operational team right now to the left side. So what we have achieved so far with the continuous integration, with the IAC concept, with the cultural elements, we break the siloed problem. We brought operation team, including security, as part of our team from the beginning. That's what the continuous delivery will help us. That's what IAC will help us. So now ops team, security team, they can see our infrastructures. We can automatically deploy to the various stage. We can automatically find out the dependencies. We can go back and change that. We can trace our libraries. We can trace any type of changes has been done. For audit perspective, if you are going to follow the GDPR says Article 42 and 14 specifically ask how you verify that developer is supposed to do the right things. This is starting from the production environment, always goes to development environment. We cover up the components. You have a full auditability for traceabilities for audit perspective. So it's a gold standard deployment. Environment parity, process parity, automated, and appropriate testing is a gold standard of deployments. So we talk about environment parity, which is another time we see in the screen, and it is eliminating any type of inconsistencies between environments, which minimize risks. So we have a same environment all the time as we build up the continuous delivery pipeline. So as a result, automation really reducing any type of manual labor, any type of human errors, enforcing parity, and helping for scalabilities. And as I said a minute ago, helping for auditabilities and make sure that putting a security in place. So to achieve the continuous deployment delivery, we have to have incremental changes. So we don't want to be deploying the whole server from scratch. It is not a continuous deployment. We are deploying only the small changes, only in environments. So don't say that I'm going to deploy systems completely from scratch. That's the reason we said at the beginning, we would like to have incremental iterative changes. That's the reason we said at the beginning, our system should be architected enough as a microservices concept or a stateless application or a modular application or a REST API, whatever the server or services you're creating should be modular. Then we can deploy the changes for a given services. Otherwise, you're not achieving a continuous deployment either. So don't really change whole systems every deployment. Change something in that system they are deploying. Maybe adding a new text box probably, or you're adding a new page in your website. You don't need to shut down whole websites. You have to push the one page that will change the appropriate pages only. So design your system, then you can deploy at a continuous fashion. Okay, that's a dependency level I discussed at the beginning. We're going to make sure that our system is capable to address any modularities. If your system is not modular, you cannot do integration, you cannot do continuous deployment. So step back, ask yourself how I should do to architect my system, then I can achieve the continuous delivery. I can achieve the continuous integration with the DevSecOps mindset, right? So we talk about the security testing. It's going to give you a lot of capabilities for doing more security testings in the delivery perspective before the production or the integration phases or the deployment phases or in the production. Like the security the testing is very well known as the Chaos Monkey from the Netflix, which is right now is the security engineering, Chaos security engineering. It's working for resilience perspective on a production environment because how it is done to make your system is resilient enough. So is it test enough to make sure that you could do successful deployment? Like you should ask yourself, how much is enough for my deployments? What the factors are my organization to automate that? Security, scalability. So we had to really design our CI/CD pipeline based on our goals. So we build up our pipeline, but we are putting reasons on top of that. What is our the barriers, or not say barriers, what is our gatekeeper to block the systems? We call it a guardrail sometimes for security perspective. So I'm going to cover up a couple deployment strategies very quickly. So when you do the deployment like a continuous delivery, continuous deployment, we have to understand engineering principles again. Like what type of deployment strategies we can use? What is the purpose that we are deploying into our production environment? Is it a business case? Maybe for business, like a canary release. Maybe you can do A/B testing for your market purpose. So define your strategies for your deployment. Is it for market strategy? You can do canary testing. You can release your code into the certain users. When you deploy your code, look the server's deployment. You have maybe 1,000 servers you will deploy that. And look at what right strategy for you. It can be a red flag. It may be a rolling upgrade. Like you can really change the server, each of the server one at a time. Go to the next one. Depends on your business case. If you are in organizations, you may not do the rolling upgrade because you have a safety critical systems maybe. Maybe you have a high transactional system. You cannot rolling upgrade probably. Or you can do the red and black for that type of case. You have an instance with A and suddenly change everything to the B. So you switch the operation A to B. Depends on your cost, depends on your business needs. You can define your deployment strategies are red, black, or rolling upgrade. So it depends on your work. But ask yourself, what is the reason I have to do continuous deployment? What my strategies are? What is my intent I have to do? And then prep your infrastructure in that perspective. So that's another example, actually. The Kubernetes and container getting very popular because much easier to deploy, much easier to scale up. Because orchestration will have to scale up all these components. That's the reason right now in the community or industry we're using a lot of Kubernetes or the similar orchestration techniques for a deployment perspective. And make sure that you have a strategy always to rolling back to any deployed services. So we don't want to have something is hanging on the board, not able to roll back to previous version. It's not a DevOps perspective either. We have to have policies and procedures and components or the code we can roll back to previous version. I think we already said all these important points, and I'm going to go to continuous monitoring, which is the last piece about the DevSecOps perspective. So continuous monitoring. So what is really monitoring? What is the reason we do the monitoring? Monitoring is a collection of any logs, any data from our pipeline, from our design, implementation, to running production. So every steps and the phases is really generating some data, like infrastructure, the collection, we're going to collect the system. Overall monitoring, we should have a generation, the system, we're going to generate that. We have to collect the data on the monitoring systems, like we may be collecting data from different tools, different servers, different environments. So based on the collection, we can create alerts in the systems. Like once we collect it, what is the purpose we are collecting data? We can put some alerting mechanisms in the systems for alerting any type of either abnormal usage or some behavior, some security problems. Based on the alert, we can act as a person to respond to alert. So we can monitor the alerting mechanisms and respond. That monitoring can be maybe outage on the systems, maybe can be some system resources, maybe some security problems. So based on alert and human do some actions to achieve that. So as a reason for monitoring, as I said, there may be many reasons. So, and typically, really, I would like to propose the monitor of everything, and definitely you can find a reason to act on it. Think about the way in your environments, in your DevSecOps environment, including production, look for the way to utilize that data. For a development perspective, maybe you can improve your practices. You maybe improve your DevSecOps process and practices. Maybe look at for usability perspective, how the user is reacting based on the user. Maybe looking for performance, maybe looking for security. So there are many reasons you can build it. So types of monitoring is actually for development perspective, operation security perspective. Like look at the reasons you are monitoring in your cases and you're collecting. So implementation detail, like you can really implement different type of monitoring systems. So when you instrument that your infrastructure, you should have instrumentations like build up your pipeline as the monitoring perspective, putting a telemetry, which is collecting data from each of the components, storing data into the centralized place, and displaying, you should have a visualization of your data and alerting the system. Let's look at the graphic version. So we would like to make sure that we are collecting data from every component of our pipeline. And then at the same time, we need to collect data from different systems, which is your production environment. Depends on your monitoring type. There are many types of different monitoring systems, like Nagios as an example, or you can use the like AppStack, or you can use the parameters. You can use the many type of the monitoring systems. Depends on your monitoring system. Either the system will feed the data to your server, or your agent feed data to your monitoring system, your data lake. So based on data lake, you can create this, you can put some alerts, and based on alert, you can alert either operators or other system users. And then furthermore, in the futures, you can use the data lake for your AI perspective, for your including your big data analysis you can do. You can do for many reasons for your data lake. I really advise you think about for monitoring data from the beginning, because it's very difficult to add it later on. When you build up any component in your pipeline, add the monitoring perspective and pipe the data from your monitoring data into the Elk stack as another example. Or you can use the Logstash or whatever the tools you can use, that's perfectly fine. And you make sure that you're gonna visualize your monitoring the data, like visualize your component, make it as visible to everybody. And one example I can use, some high performance IT organizations are able to monitor from the beginning of the application all the way to the production, and developer has the dashboard. They can see the build process. They can see the number of cases closed. They can see how the system is running production environment, makes them to feel they're part of it. So it makes them to understand the problems in between, makes them to really communicate and collaborate that. That's how we can improve the communication and collaboration, by sharing and visualizing data from the pipeline itself. The couple metrics we have to put into the pipeline. So metrics is the component and you can put in your pipeline to measure where you are, how you are responding to the needs, how you're responding to the work needs. So really metrics can define for your purpose, but these are the common metrics. Like somebody calls it DORA metrics, perfectly fine, but typically we would like to measure our deployment frequencies, because how can we validate yourself, how you're doing better? How you compare your organization 2 years ago or 6 months ago, or last week. We have to improve our quality by using this metrics. So change lead time as an example. How much time takes a work from committing code to the production environment? How much quickly we can recover from the errors? How much we're responsive to any incidents, which is MTTR, MTTD as an example. And time to value, like how much time takes from feature request from user creation always goes back to the business fail as an example. Or the approval ones. The last one is the time to patch vulnerabilities. Ideally, that should be a minute, sometimes in a second if you can, because adversaries are racing with us. If your system is not resilient enough, then how much you can patch how long does it take, how much takes longer to patch your system will be very difficult to patch your environment because very challenging to respond to your business needs. So you can expand the metrics, but it really depends on your organization, depends on your needs. But these are the common metrics I would like to advise, and what's the description of each metrics that you can use. So as a continuous monitoring, really you have to remember, make sure that you're collecting data, remember your metrics that you're going to use, and learn from the mistakes, and monitoring tech and tools, then you can go for your work-wise. So that said, it's getting closer to the end. I would like to really share the 3 slides with you as the takeaways. So make sure that DevSecOps is the people. That's human. People requiring a heavy collaboration between all stakeholders. Team members are talking constantly each other's, with the dev, with ops, with the security teams. The mechanisms are, please make sure the chat, email, wiki, whatever the platform it is, then you can use. Make sure that people are hard of the work. Next one is process. Please build up the process that enable the people and succeed in using a platform to develop a secure application. So process is important. It's not a wild west. We're not saying that everybody do what they can do. It's requiring some discipline, requiring some policies for open source usage, requiring some policy using a dependencies libraries. Okay. Make sure that you're supporting your organization as the manager or a leader or a developer following the same guidelines. Like, don't commit the code 2 weeks later. Commit the code when you have done the change so you can contribute the continuous integrity. This is a process pieces. Or sharing data in between, it's a process pieces. So lastly is the platform. Make sure that people are using process to build up the software based on the platform. So our platform should help to the users to build up the software. It's basically, I call it a kind of like a stool, like a table, or the basically a quick chair with the 3 legs. So 3 legs are people, platform, and then the process. So if one of the legs is short than others, your table is not going to stay as balanced. So we make sure that we have a balance with the people, which is knowledge and skills. We have a balance with our process. We don't want to have a heavy process because heavy process block the platform or people not to use it. So it's kind of like a layer. So we have to coordinate that as a team, as the overall work with the platform pieces, with the process pieces, with the people pieces, so we can achieve that. So what we learned so far, we learned about the overall DevSecOps. We don't have covered up, we didn't talk about the continuous CI, but it's kind of approval process. I skipped that module. We learned about the pipeline. We learned about the CI and CD. So end of the day, I would like to say everything is code, what we do today. What we write, I like that comic. Someday, we won't even need the coders anymore because code is going to write the code. Everything will be code. That's what I see it is. So I wish we had time to ask the question, Yusuke. It's almost 3 hours.
Yes, and it's now it's right on noon. So we I don't think we can get the questions, but you have sessions tomorrow as well, so audience can ask you the questions tomorrow as well. And lastly, can you cover up any references, documents?
Yeah, exactly. So in the references, please look at, actually I can go here. If you go to the GitHub page, and I have been constantly updating the build up DevSecOps environment through the GitHub page. You can take a look here. You can look at the YouTubes. As an example, take the screenshot if you're on the screen. So follow the GitHub and search the SOI. or you can go to the SEI website, and I have been publishing the blog post or writing a webinars, delivering blog posts, webinar, or podcast. I have been constantly speaking, so please engage with me and throughout that channels. And lastly, really, if you have any questions, send me email, and just send me email for any question. I'm happy to talk. Maybe you have a unique case, you were looking for a solution. I'm happy to work with you, recommend some solution for your case. So happy to reach out to me anytime. I'm happy to talk with DevSecOps or DevOps anytime.
Great, great. Thank you. Thank you very much. ではですね、ちょっと1日目を締めたいと思うんですけど、
So we'd like to close the first day. The final part we had to rush through, and for people who are not engineers, maybe it was a bit too technical and a bit difficult. But if I can just add Kubernetes and containers, why do we use them? For example, YouTube that you're watching, Kubernetes and also containers are being used. The VM, virtual machines, has to be run on OS, but Kubernetes, you have a lot of containers on top of OS. So when you start up your personal computer, it takes time until the OS starts up. It's the same with the servers. But for Kubernetes and on containers, a very agile development or environment-dependent developments, not just the features, but on the backside. So how many workload can be handled? All that has to be done agile. Let's say on YouTube, all of a sudden, so many people start watching YouTube. If it exceeds the capacity, sometimes it falls down, and we don't want that happening all the time. So just like containers, we have to have something that starts up very quickly. Pokemon Go, people were saying maybe 1 million or 500,000 users will be using at one time. Actually, 3 million came. And if you have these containers, you will be able to deal with such situations. So container Kubernetes, I believe Tsukagoshi-san from Google Cloud will be talking about this. So Mr. Tsukagoshi, if you are watching this, I hope that you can include it in your presentation. And for tomorrow, we have a keynote speech. Nicholas Shalin will be talking, Chief Software Officer of DoD. And he will be talking about how to utilize these technology stacks. I believe he will be talking about that. At DoD, well, we're not Facebook or Google, we are DoD. Some people might be feeling that they don't want to do this. But for these people who are reluctant, how did he try to change their mindsets? We in Japan are about to have a digital agency being started up. So for people who have been sticking to the conventional ways of working, how can we transform? I believe we can learn from this session. And also, a CIO at the DoD, Linton Wells, and the 5G and the danger of Huawei has been pointed out by him. And about 2 weeks ago, I think, the Self-Defense Force, about a little more than 200 are setting up a cyber team, and this will be increased to about 1,000, and therefore the Defense Ministry wants to have a bigger budget. So how do we increase 200 base to 1,000 personnel? I believe we will be hearing how that could be done from Evan Dornbush. He was at NSA, where Snowden was, and he has been a software developer. He was in charge of security, and he has created a training program for cyber engineers. And I myself, if I may do some ads, AI project systems, how can we create these things? I have produced a book for business people about 2 years ago. Now, AI, ML, or machine learning, what are the cyber threats to them? And today we heard about DevOps, but AI in the operational environment is really related to DevOps, and therefore I hope that I can keep that in mind as I make my presentation tomorrow. Dr. Tomabechi, anything to add? Well, as I said at the outset, Carnegie Mellon computer science classes, I believe you won't be able to hear this. It's the #1 computer science grad school. Hasan's talk is something that you will hear in the master's course, all squeezed into 3 hours. Of course, in a classroom, you will be able to see actual demonstrations, you will do a lot of work, but the contents were squished into 3 hours. I believe this was a really rare opportunity for you to hear that. So I'd like to applaud Hasan, and tomorrow, it seems that many people want to join in, but people you will not be able to meet in ordinary times, like Hasan or Nicholas. If we asked him to come to Tokyo, he will have to come to Yokota Air Base on a military flight. And we won't be able to pay them money, but we may have to really pay for the transportation. But because of the coronavirus, we are capable to contact them and hear these lectures on the web. And yes, we have been eager to invite him, but it's really a big thing that we have these major speakers. And point 3 was a spinoff from NSA. And tomorrow, and we will hear people from the core of the U.S. intelligence society. Of course, they will not introduce themselves as that, but we will be hearing from speakers who usually we will not have been able to invite to Japan. I have been listening to the classes, and I was fearing that we can't hear this quality lecture in Japan. In Kobe, there was a Japanese school of Carnegie Mellon, but you had to travel to Kobe if you wanted to hear the classes. But this is a new style that we are trying. In the 3 hours today, I believe it was a great success because of our sponsors. And you have been also navigating. But DevSecOps, not just DevOps, but I believe he has become an evangelist here in Japan by tying up with the teachers at Carnegie Mellon. So thank you very much. And thank you. Let's see you again tomorrow. And thank you for joining us today.
DevSecOps Days 東京は DevSecOps を推進するためのコミュニティ活動に賛同してくださる多くの企業、団体から支援を受けています。プラチナスポンサー、レジリエンスジャパン、ソナタイプ、データドック、レッドハット、ゴールドスポンサー、マイクロソフト、コグニティブリサーチラボ、Google クラウド、シルバースポンサー、ブレインパッド、HRD、プロファイルズ。講演、アメリカ大使館、カーネギーメロン大学ソフトウェアエンジニアリングインスティテュート、カーネギーメロン大学サイラボ、日本ディープラーニング協会、テンソルフローユーザーグループ東京、経済産業省。
Modern software applications consist of 90% open source components. These open source components often contain security issues. As we rely on open source software, companies have to reconsider their approach to security. Traditional manual processes based on whitelist and blacklist do not scale. They can really hold you back, especially when competitive advantage relies on speed of software delivery. That's why it's essential to build quality from the very beginning by adopting a shift-left mindset. Shift-left means integrating security practices early in the development lifecycle before your project reaches the finish line. Sonatype's platform helps you to automate open source governance early and everywhere in order to scale DevOps within your organization. Visit sonatype.com today for more information.
Because we've been this way from the start. Because a solution for one can be harnessed by others. Because clouds that compete can still connect. Because innovation needs collaboration. Because a revolutionary approach to software can transcend enterprise IT. Red Hat. Our code is open.
ビッグデータや AI 技術が脚光を浴びるデータの時代がやってきた。巨大企業もベンチャー企業もデータを大きな経営資源と捉えビジネスに取り入れようとしています。15年以上前からデータ活用の可能性をまっすぐに信じてきた私たち。今こそ一緒にデジタルトランスフォーメーションで開けるドアがたくさんあると思うのです。
持続可能な未来につながる扉、成長し続ける最適な意思決定、
データ分析の民主化、
顧客体験を磨き続ける世界、意味のある仕事を作る、
誰も想像できない大きな成功、イントゥリアンノース、
製造の矛盾化、できたらいいなを形に、
仲間の笑顔が未来の笑顔を作る。
HRD グループは科学的なアプローチで人事や組織の改革を強力に支援しています。今、多くの企業がデジタルトランスフォーメーションに取り組んでいるのではないでしょうか。デジタルテクノロジーを活用することにより、営業やマーケティングの見直し、業務プロセスの自動化が様々な企業で実現されています。 では、人材や組織に関してはどうでしょう。一人一人の才能や個性に合わせた適材適所の実現や効果的なコミュニケーションの実践はデジタル化とは無縁の勘と経験に頼っているのが現状ではないでしょうか。このような勘と経験に頼ってきた人事や組織の課題もデータにより解決する時代になってきています。私たちの提供するディスクとプロファイル XT は科学的検証に裏打ちされた人材測定ツールです。一人一人のモチベーションの源泉やそのポテンシャルを見出すことで組織や人材の課題を解決します。全世界でこれまでに6000万人、10万社、日本でもこれまで120万人以上の顧客が効果を実感しているソリューションです。これからのデジタル時代の企業における改革の本質は、人と組織のトランスフォーメーションにあると私たちは考えています。HRD グループのディスクとプロファイル XT が組織や人材の改革を可能にします。効果的なコミュニケーションによる組織力向上に興味のある方はディスクで、社内の適材適所の実現や人材のポテンシャルを見出すことに興味のある方はプロファイル XT で検索して、ぜひ一度ホームページからお問い合わせください。DevSecOps Days 東京のコミュニティ活動は皆様からの支援で成り立っています。今後のコミュニティ活動への支援にご興味のある方はお気軽にご連絡ください。